All right. Hello. Part 13. Part 13. It would have been good if I'd done this on Halloween, because then that would have been spooky. But I didn't, and so it isn't. But thank you for joining me anyway. I am making a WebAssembly interpreter, and I'm trying to do that in Ruby. I am doing that to have fun, mainly. I'm doing it to demystify WebAssembly for myself, maybe for you, optionally, and just trying to share how I do it. I want to prioritize having fun over making it functional and, fully working. It's fine if I don't ever get a fully operational WebAssembly interpreter out of this, as long as I've enjoyed myself. I want to try and get it correct, try and build it in a principled way, even if that means sacrificing performance. I want the code to be as clear as it can be, even if it's not very clever. I want to try and do it in pure Ruby as far as possible, which is a little bit challenging, but, it's working so far. And I want to try and do it with no dependencies, which is also proving a little bit challenging because it's meant that I've had to implement things like floating point numbers that otherwise I could have used somebody else's gem for. But oh well. I think it's going okay. I think I've survived this far without installing RSpec, so I think that's as good as I could have hoped for in terms of not bringing on even development dependencies, let alone runtime dependencies. So I've got loads to do today, so I'll just keep this brief. But before I get stuck into it, I just wanted to have the usual chance to just reflect on how things went last time. So firstly, amazingly, I've got simple control flow working now. I've got loops and blocks and branches, and you can read and write to local variables, and you can read and write to memory. And I realized that for the first time, it feels like this interpreter can run actual programs and not just act as like a calculator for intentionally difficult arithmetic expressions. That floatexprs.wast test script has got loops in that compute actual algorithms. So that's exciting. It feels like significant progress. So I wanted to just recognize that during the last stream, I did get to the point where I was actually running things that looked a lot like computer programs, and that's pretty cool because I'm making an interpreter. So that's the good news. The bad news is I'm a little bit terrified of the next step, because the final part of that floatexpressions.wast file has got defines a function called tau that requires me to evaluate like a flat list of instructions rather than a nice nested tree of them. And until now, I've been able to get away with ignoring the fact that WebAssembly requires or executes on a stack machine, because all of the expressions that I've seen so far have been like in a nice prefix notation with the operation first and then sort of nested S expressions for the operands. So I've been able to just recursively evaluate them and use the Ruby stack to pass the results back to the operator that needs them. But that tau function has got the arguments in postfix notation, with the operation comes after the operands. So I can't get away with ignoring the operand stack anymore. So I'm going to have to try and introduce that. So I think there's going to be a lot of refactoring necessary to kind of get that inserted into the interpreter such as it stands at the moment. And that does terrify me a bit, because the evaluate method that is the heart of the interpreter has become so huge and messy now that I'm afraid to touch it. I've just been piling more and more instructions into it over time. And I haven't had any real organizing principle for doing that. It's just got a lot longer. So there's lots of duplication, and there's no real sense of which parts of it are sort of conceptually related to each other. So I think I'm going to have to spend some time cutting that method either cutting it up or just cutting it down to size, basically finding a way to make it more manageable before I can hope to start introducing an operand stack. But hopefully I can get it under control. And if I can, then the stack shouldn't be too hard to like introduce incrementally. And I've sort of made a plan about how I might do that. So I guess we'll see how that plan goes. Okay, that's it. End of retro. Oh no, that's what am I doing in OBS? Okay, there we go. All right. I was just confusing myself with what screen I was on, but I'm on the right screen. Okay. So, WASM spec path equals spec test.sh. All right. So I'll bring up the pending test failed successfully. Okay, great. Yeah, at some point I want to turn the color off because the red is really terrifying, but then you get green and you're like, oh, okay, the red wasn't real. So we're looking at this float express.wast. So that's what's pending. So all of this stuff is fine. In fact, we're getting all the way through all of this stuff, which, like I said, includes loops and function definitions and local variables and memory access, and I'm very happy about all of that. But then we get down to the bottom here. Test an approximation function for tau. It should produce the correctly random result after and only after the expected number of iterations. So this is just testing that this function works properly. But the reason why I didn't try to get this working last time is because these instructions are not... This function definition doesn't look like the other function definitions that we've seen so far. Like, I mean, this is a good example that like all of the S expressions we've seen so far that constitute like executable expressions, like the bodies of functions, have always just had like an operation in this sort of prefix location, and then the arguments are always nested S expressions. So like I said, I've always just been able to recursively evaluate all of these nested S expressions. They all return, the evaluate method returns the value of that expression. And then this operation at the top is able to just take its arguments and, you know, compute a result and return it, and everything's fine. But this tau function is not written like that. And I don't really know what the deal is here, because I haven't done any WebAssembly programming. I don't really know. I mean, clearly this is also a legitimate way to write a WebAssembly program. And so, you know, I have many questions, chief among which is like, which one of these is like the canonical notation? Like, are you supposed to write them as nested S expressions like this? Or are you supposed to write them? I mean, you know, part of what frightens me about this is that there's basically, you need a parser to be able to even tell. I assume that white space isn't significant here. Like, you need a parser to be able to tell that, well, this is an instruction that takes, well, it's sort of an argument, isn't it? Like, f64 const takes an argument of sorts, and local.set takes an argument of sorts. But these, you know, this local.set also needs to get one of its arguments from, well, is actually this constant. So, yeah, a couple of things going on here. Firstly, a parsing problem where it's like, in order to chop this up, we can't just say, well, chop it into pairs of atoms from the S expression, because here, you know, block doesn't go with anything. Block is just on its own. And even this I32.less than doesn't have any like immediate arguments here. It just operates on whatever's on top of the stack, presumably, that you'd have. Well, we're going to have local variable 0, and we're going to have a 1 pushed onto the operand stack, and then this is going to operate on them. So both syntactically and semantically, I am not in any way prepared to to execute something like this. I mean, of course, syntactically, this is still just an S expression. It's just that after all of these nicely nested S expressions here, now we've just got what to my S expression parser looks like, just a long, undifferentiated array of atoms. And in this file, they've been formatted nicely with new lines and stuff. But essentially, this is just one big, long stream of tokens. So really, there's two problems here. One of them is chopping up this input into actual executable instructions, identifying of all of these atoms, which ones are the actual operations and which one are sort of immediate arguments to those operations versus operands that are going to come off the stack in the stack machine that this is supposed to be executing on. And I suppose the other problem is we haven't got a stack. There isn't, even if I knew where the boundaries of all of these operations were, I don't have a stack. So I'm going to have to introduce one, because my previous strategy of just using the Ruby call stack because everything was nicely nested is definitely not going to work. Because these instructions appear not in the order, And in fact, when I'm executing this, f64.const +0, I don't even know which future operation is actually going to be consuming that. Like, it might be that there are the subsequent instructions push loads more values onto the stack, and it's not until 100 instructions time that we actually need this value. Or it could be, as in this case, the immediately next instruction. So I just need to have this whole implementation needs to become more imperative, right? At the moment, it's just a recursive method that calls itself and the return values plop out in exactly the right place to be usable. Instead, I'm going to need to sort of iteratively consume atoms out of this S expression, firstly to form complete instructions, and then to mutate a stack so that when I crack on to latter instructions, the right values are on the stack when those instructions execute. So that's the nature of the problem. So like I said, I did make a little plan. I don't think I've added a few to-dos here for going back and reading over the code before turning the webcam on. I sort of saw a few things that I would like to clean up. So these are new, I think. I said I wanted to extract a define function helper. So if we look at, there's an invoke function helper. So down here, when we want to invoke a function, we can just call a thing. But then to define a function, there's this big chunk of code up here, and it sort of felt like that should probably be extracted to sort of, to balance the invoke function. There should probably be a define function. Tidy up and or break apart evaluate is doing quite a lot of work there. Like that's a big job, and that's probably what I'm going to have to do now. And I've said organize numeric instructions by arity so they can share operand handling if we're going to add a stack. Yeah, so I'm sort of concerned about the amount of code duplication that's inside the evaluate method, and I'm worried that if every one of these instructions also needs to start manipulating the stack, if they need to be popping arguments off the stack and then pushing results back onto the stack, there's going to be even more code duplication. Whereas if I had all of the binary instructions together, or all of the 2-argument instructions in one place, then before all of them, I could just have a single line of code that says pop 2 values off the stack and put them in local variables. And likewise, if I put all the unary arguments in the same place, so all the unary operations, all the ones that take a single argument, then again, I can just have one line that pops one value off of the stack, and then all of those implementations will have it in a local variable. So my motivation there is to try to avoid having to go through and update the implementations of 50 different instructions just so that they can all pop 2 arguments off the stack, for example. I want to kind of consolidate things so that I can share code. I had some thoughts about float.rb as well, but that's I'll come back to that. So here was my introducing an operand stack plan. And this doesn't, I don't think this gets us close to dealing with the sort of essentially parsing the atoms from the S expression problem. Like that's that's the next problem. But the first thing we need to do is to be able to get to the point where all of these instructions, when they're evaluating, are using an explicit operand stack and pushing and popping from it rather than using the Ruby call stack. And to do that, I think, so here's my 5 steps, very detailed. So number 1, clean up, evaluate. And as you can see, this consists of several different jobs. So I want to reduce the duplication that already exists. Consolidate operand handling, that's what I was talking about, like organizing by arity, basically. Break up into multiple smaller methods. Like right now, this evaluate method is just way too long. It just goes on for ages. In fact, why don't I don't know why I didn't do this sooner, really. I could make this window taller, can't I? Yeah, that's a bit better. why have I waited till part 13 to start doing that? I don't know. So like you can see, it's just very, very long. And I find that very intimidating. As someone who is about to try to modify the fundamental workings of that method, the scale of it is a little bit intimidating. So I want to, I might spend an hour or two just doing that, just sort of cleaning up this evaluate method so it's better organized. If I can extract some methods from it so that instead of one long epic method, I've got some more focused sort of helper methods that it can call into, then that would be good. So that's the first step. Then incrementally add operation results to stack. So what I'm talking about there is, let's say local.get. If I've got a stack, then here, and I've said like leaving return values temporarily. And what I mean by that is at the moment, this chunk of code returns on the Ruby evaluation stack, the Ruby call stack, it returns the value of the local variable. What I'm suggesting is that I could also push that value onto another stack, an explicit stack, and that won't break anything. It will just make this particular instruction sort of compatible with the explicit operand stack. And then once I've said it incrementally, because I can sort of start doing that, and then at the same time, this doesn't really come later, this is at the same time, I can also fix up other instructions to read. I've put operation results. What I mean is operation arguments. Yeah, okay, I think, well, I suppose I do mean operation results. What I mean is the results of other operations, read them from the stack. So this is saying if I can find operations whose arguments already add their results to the stack. So in a situation like one of these expressions, like if it was the case that local.get and f32.add and f32 square root all did this thing where they dumped their return value onto the explicit stack, then f32.mul could ignore the result of the recursive calls to evaluate that it makes in order to evaluate these arguments, and then it could just pop its arguments off of the operand stack because all of these instructions would have pushed their results onto it, if you know what I mean. So the reason I'm doing this, the reason I want to do this, is to avoid a sort of boil the ocean situation where I'm trying to just make one massive change that completely, that switches the whole thing over from using the Ruby call stack to using an explicit stack, because I think the chances of me being able to do that as a single atomic operation that works are very slim. So the idea of doing this incrementally is that I can, boil the ocean a teaspoon at a time, and hopefully I'll get to a point where it's working. And if it is working, then I'll be able to remove the explicit arguments. So stop using the result of recursively evaluating other expressions, and then remove the explicit return values. So don't return value here. It just gets pushed onto the operand stack. So that's the theory. Let's try and actually do some programming, because I'm already 20 minutes in and I haven't actually typed anything yet. I do think that was it? I do think I think this is an easy piece of low hanging fruit. Is just getting rid of this big chunk of code here. I think it's easy to pull that out into a helper, so I'm going to do that. So what's that going to look like? It's basically the helper is going to return this, right? So this thing here is going to call like, well, it doesn't exist yet, define function, and I think it just needs, yeah, this just needs the expressions. And this isn't necessarily the body of the function, because this includes all of the preamble about like what its name is and what its type is and what its locals are and stuff like that. So one of the things this is going to do is populate the body of that function, but it's not the only thing. So I think it's like that chunk of code there. Are we in private methods already here? No. When do we get into private methods? Oh yeah, okay, down here. Okay, well, I'll just put it here. Define function expressions. That seems straightforward. That's like a warm-up. Test. I've decided to stop suspending Vim because it was such a nightmare last time. Okay, great. So that's just extract define function helper. All right. Well, that gets me an easy win. I mean, this tidy up and or break apart evaluate. It's like that's probably going to be this whole stream. But that one was nice and easy, so I'm grateful for that. What's next on my to-do list? Well, I mean, it's just going to be cleaning up evaluate until the end of time, I think. So one of the problems with the evaluate method, one of the many problems, is that there's a lot of duplication in it. And I think the worst, I mean, there's some here with the loads and the stores. Maybe that's something to come back to. I just whipped this up quickly last time because I wanted to be able to support this optional static offset here, but I'm just looking at this now, I can see that I could combine these two. So maybe that's something to look at. The thing that I was particularly agitated about was all of these implementations of trunk. And it's not an important method, it's just that there's not an important instruction. It's just that there are lots of different variations of it, and I ended up duplicating it over and over and over again. In fact, I think I've already got a to-do in here. Yeah, remove duplication in trunk instruction implementations. And I think that this is actually one of the largest contributors to the evaluate method being so long, because you can see it's like pages of just truncation code, and it really is just a single instruction with parameters, so I should be able to implement it as a single implementation with some conditionals inside it. So let's have a look at how I could simplify this. I mean, the reason why there are so many of them is that it varies along 3 different axes. Is it 32 or 64-bit? Is it signed or unsigned? And is it saturating or not saturating? So I'm going to try and see if I can combine those. So let's think about... Yeah, I think the the 32 versus 64 is the easiest thing to sort out. So this is 32S, 64S. In fact, is there a thing where I can just get like this? Yeah, okay, this is what I'm going to do. I'm going to say here, float bits. So that's going to pull the 32 out. So this thing here will become float bits. Bearing in mind that bits is actually the size of the integer that we're producing after this. So we could be producing a 32-bit or a 64-bit integer, I think. Yes, so if I do that, then this can just be this. You know, that sort of consolidates those two implementations essentially. So now I've got 32 and 64-bit implementations that's parameterized on the number of whether it's 32 bits or 64-bit floats. So one would hope that I can do the same thing here. Yes. So this will be float bits. Float boat. Wow, that was a good slip of the fingers. Yeah, this is just the same. That's all that's changed here is the value that's used up there. Oops. So 32 or 64, 32 or 64, 32U. Oh yes, it's the same deal again. Okay. So this goes up here. This goes here. And then I need the float bits thing here, and this needs to be float bits. And is this the last one? That wasn't quite as bad as I thought it was going to be. Yeah, that was it. Okay. Just goes to show I should be braver about this. Okay. So you can see there's still a lot of duplication there, but now it's halved. So now we've got the signed saturated, unsigned, and unsigned saturated are the 4 different bits there. Let me run the tests and make sure that it still works. Okay, great. Okay, so let's say combine 32 and 64-bit implementations of, what is it, trunk F, trunk, well, let's just say, what is it, trunk, there's like optionally a SAT, and then it's 32 or 64, and then it's what is it, S or U? I'm just trying to think of how to. Oh, it's 64, not 63. I was trying to think how to explain what this is. Maybe that's better if I just put it in. Optionally SAT, 32 or 64, S or U. maybe if I put an asterisk in there, it'll sort of highlight the fact that the asterisk is the thing that we're combining, and then we still have sat or no sat, S or U. Because I'm thinking about what's my next commit message going to look like. It's going to be like an escalation of this, I suppose. Is that right? Trunk sat. Oh, it's F. Okay, fine. All right. So next, I mean, this is already improved, but let's keep going. I think signed and unsigned is probably the easiest next thing to deal with, because those don't differ very much. I'm just going to put a new line in there. So I need more than one because there's new lines down there. So these are basically the same. The only difference is whether we call unsigned hold on. That gets truncated. Oh, okay, yeah, I wasn't reading it properly. It's actually a little bit hard to see. So here the truncation happens inside there. I was like, why doesn't this float get truncated? And it does. It just gets truncated inside there. So I'm going to need, in addition to float bits, I'm going to need a Boolean that tells me whether the input is signed or not. So let's say signed input is operation end with S, or maybe underscore S. So that gives us a Boolean. And in fact, the float does get truncated either way. Hold on, sorry, I'm making a bit of a dog's dinner of this. So those are all of the instructions we're supporting. The float bits line is the same. The format line is the same. And what we're saying is if signed input, I'm just doing this to help me think about what this looks like, then we do that, else we do that. But essentially this line is the same either way, right? So this here is essentially the result. So we do that. I won't even bother thinking about what that's doing. And here, the result gets converted, and here it doesn't. And I remember there are other places in this code where we just unconditionally pass things through one of these signed or unsigned helpers, because I was able to reason out the fact that it actually didn't matter because that function didn't change that value. But in this case, I just can't even be bothered to think about it. I think this is just a completely mechanical transformation. So the semantics should be exactly the same as before. And that's as much energy as I'm willing to spend on it. So I'm not going to think about that any harder. Okay, well, I haven't broken anything yet. If it was broken, then that test would have failed by now. So let's do the same thing down here. So this, again, to combine these two. So again, we're going to need to know whether it was a signed input. So the format is blah. Now in this case, it doesn't get... Okay, right. So actually it is called result down here as well. Let's just look at what happens here. So what I'm going to do is I'm going to sort of eat my way through this one line at a time. So float bit signed input format, that's all the same. And we've done this line. Now result, that's the same. Result, nan, 0, infinite result, result truncate. So the sort of result calculation part is also doesn't vary depending on which one of these we're looking at. Size is one shifted left bits. That's the same in both cases. Okay, now the min max is different. So that sort of filling in that sandwich has to change there. And then here it says result equals result clamp. Yes, that's the same in both cases. And then down here, oops. Okay, so it sort of ends in the same way as this one, right? It's like if it's a signed input, then convert it to unsigned. Otherwise, don't do that. So all of these bits stay the same. I just have to calculate the minimum and maximum here. So this is if signed input. This was the first, right? Yes. So it's going to be else this one. Can I just squish all these together? I think so, because that's conceptually what's going on here. Size is only being used in this minimum and maximum thing. The purpose of this chunk of code here is to clamp the result. And that's really the point of this. Well, that is what this saturating truncation does, is that if the result is finite but out of range, we clamp it into the range, and this takes care of the case where it's infinite or is not a number. So I think, unless I've just made a silly error, I think that's right. So now I've only got 2 implementations of trunc. Again, I think if they were wrong, I would have seen a test failure by now. So the really challenging part is writing the commit message for that. So this is combining the signed and unsigned. Okay. So combine signed and unsigned implementations of trunc may or may not be sat. Maybe 32 or 64 star instructions. Okay, I mean, I really don't think that thing that I'm writing in the commit message is very helpful now that I look at it, but that's definitely boiled it down a bit more. And so I guess the final party piece here is doing this, right? So can I make saturatingness also a parameter of this chunk of code so that I finally got what I wanted, which is just one big messy implementation. So I've got I try and keep track of where I've got to. So flight bits and signed input are common. I also want to know whether it's saturating. Problem is the sat sort of lives in the middle. If I just say operation include sat, because then that lines up with the _s. Or I suppose I could ask if it starts with trunc sat. No, that's fine. I know there are only 8 possible inputs to this, and I know that this will definitely catch it, so that's fine. So in this other implementation, float bits, signed input, format is the same. Result is not the same. So what we'll need to do here is say, well, the result is going to have to be, it's going to have to be the one without truncation. And then we're going to have to say, like, if saturating, do the saturating, truncation, else, I guess this is returning result, right? So this thing is just going to say result.truncate. So that takes care of the non-saturating case. Oh, and then this is the end. Okay, so this is the saturating truncation part. Have I got another copy of this? Yeah, that's down there. So do I want to... This is result truncate is in the else clause in both cases, which I'm not totally crazy about. I think what I'm going to do is make this a separate... It's just way tidier if I can... I know that I'm essentially testing the same thing twice, but here the purpose of this is to return the sort of initially truncated result, which is accounting for nans and infinities and stuff, and then this is a separate kind of clamping operation. Okay, I think that's correct. Let's see what the computer thinks, which is really what's important. The computer also thinks it's correct, so that's good. Now, what I'd really like is for there to just be one result.truncate here. This is the fall through if neither of these is the case. So I think here I can lift this up. And then this is saturating and result is infinite. And then this just becomes the else. Okay, I think that's right. All right, so now all of that, I mean, it's still, well, at my current ambitious window size, it's still a full screen full of code, but I think that's a big improvement over what we had before, so I'm glad about that. Combine. I mean, what's the right way to phrase this? And also, what order does it do them in? Oh, the unsaturating ones are first, and then the saturating ones are first. So combine unsaturating and saturating implementations of trunc star underscore f 3264 underscore su instructions. And yeah, I mean, I think the way that I've invented a weird syntax for writing those is not really helping anyone, but I don't care enough to go back and change that, because I think I just wanted to get that out of the way, and now it is out of the way. So that's good. Remove duplication in trunc instruction implementations. Okay, so that was a good sort of warm up, and has slightly helped. But now I think I'm going to need to what do I want to do first? Let's have a look. I mean, there's so much stuff that's potentially wrong here. Um, hmm. I think so. One of the things that happens a lot, in fact, well, actually, not in that code we were just looking at, but there's a lot of this. There's a lot of get the bits from the beginning of the. So, like, get the number at the start of the instruction that's the 32 or 64. And there's also this, for all of the numeric instructions, there's this idea of getting the, like, the operation, you know, the bit after the I32 or after the I64, the sort of add and sub and mul and stuff like that. And so I wonder, and I think for the F, the ones with F as well. Yeah. So that seems like this stuff about finding the number of bits and the operation feels like stuff that could just live once at the top here. And then all of the rest of this code could make use of it. So I'm going to do that. Let me just, I have to change something in my stream software. But then I think we can just go for it. All right, is this working? I think so. Yes. Okay. That looks a lot healthier. So yeah, what I'm gonna do is pull out. Again, I'm still just sort of warming up here, but I think being able to here have something that's like, I don't know, bits is equal to something and operation is equal to something, and then all of the places in this where I'm assigning those, I can just consolidate into the one place. I mean, the thing that would be really nice to do would be, like, what I sort of wish I could write here is to have, so these are numeric, what I will call numeric operations. If I could write a regular expression for those and say, start and end, well, if I make this, I guess I've already decided I'm making this an extended regular expression. So it's either a floating point or an integer operation, and then it's got some number of bits that's either 32 or 64. And then there's a dot, and then there's what we're calling the operation. Like, that's the format of numeric operations or instructions or whatever you want to call them. I should probably get my terminology straight at some point. I don't think operation is even a WebAssembly thing. So that's the format. So what would be really nice is if I could do something similar to what I did in Float, where I have this refinement that lets me match a regular expression and just pull out these. So if I could say, oh yeah, the expression is the sort of, what do I want to call that? Do I have a name for that? Do I call it an operation, or do I call it an instruction, or? I think I was using operation to mean the bit after the dot. So like here, I was, const would be the operation. Oh yeah, look, I call that whole thing instruction. I think that's probably not the right word because the instruction is probably more than one atom. But for now, I can say that the expression is the instruction and then the arguments. And then I can say something like instruction.match numeric operation regex, and then I can just match that into bits and operation. I guess this actually has to, because there are instructions that don't match this, but if this does match, then it will assign those two local variables, right? Now, I can't do this. I can't do this because I don't have that refinement, but I can fix that. Other than that, is that okay? Oh, I need to call 2i on that, on bits. So this actually needs to be like, if that matches, then bits equals bits 2i 10. And then that will set me up with the instruction and the arguments, and then all of the lines that are saying bits equals instruction slice, instruction slice. This type here, is that being used? No, that's just being used to get, well, not just the bits, but also the operation, which I'm also getting at the top there. Extend bits. Oh, right. Yeah, okay, that's different. That's actually, that comes after the dot. So I'll leave that alone. This one also comes after the dot. That's looking inside the operation. Float bits is looking in the operation. This is another place where it's getting the type just to get the operation. Integer bits. Integer bits. Okay, well, I think that's all the places where that's being assigned. What about operation? Oh, that's reassigning it. Okay, well, I mean, that wasn't a huge win, but it does. I have at least sort of lifted out part of the setup of this thing. Now the problem is that isn't going to work. Yeah, no implicit conversion. So I need to. What I want to do is reuse that. I'm just trying to understand this error. No implicit conversion of nil into integer. Mask helper. I'm not quite sure. Oh, I suppose that this match just fails. I suppose that's what it is that because that deconstruct keys is not defined, that just returns false, and so we just don't get the number of bits, which is obviously quite important. Okay, so, all right, so to make this work, I need to extract that refinement that I wrote, that I think is in the float class. So let's go over there. Refine. Oh, it's right there. Where shall I stick this? Let me stick it in helpers for now. This isn't necessarily the best place for it, but okay. So now that's helpers match pattern. And then back in here, I suppose I can do using helpers match pattern. And then hopefully if I run the tests again, I will have a bit more joy. Yeah, it seems to be working, doesn't it? Okay, that's good. All right, so I can make a commit. Well, what I'll probably do is do this. So this is extract match pattern helper module. So that I can use the same refinement in wasm.rb. And then the rest of that change is all of this. So this is just lots of bits. Looking at this diff, like they all say instruction.slice. Is that all that instruction is being used for in those cases? Because if it is, I can stop. Because instruction is already being bound to a local variable at the top there. So any of these places, I don't think we need it. So yeah, in anywhere that's got instruction, I think I can just get rid of that, because that's already being bound up top there. And in all these cases, it seems like it was only being used to get the number of bits anyway. Let's see if that still works. Line 104. Oh, hold on. This isn't inside. Did I find... I think I removed one. From the... Yeah, that's not even inside evaluate. That was overzealous. Let's try the test again. Okay. I'm going to move this window up slightly because the microphone stand is in the way, and so I can't see what I'm typing, which is not great. So yeah, that has actually, I mean, it's not a massive improvement, but it has actually removed a bunch of lines. I think it was worth adding a few lines at the top there to clear that out. So let me just do one last. Instruction. Oh yeah, and that's the one that's not relevant. Okay. Okay. Cool. All right. So let's just say Slice out bits and operation at the start of evaluate. All right, well, I'm just going to have to basically keep turning the crank on this and see how far I can get with cleaning it up. So I suppose an obvious thing to do here is that this is actually detecting whether... So one of the things I said I wanted to do here was break up into multiple smaller methods. It seems like there's, in here, this is like handle numeric operations, right? And then this could effectively be else, you know, handle everything else. But what is the... So it's going to be something like case expression. Or actually, maybe it isn't. How does this work? Let's actually find the... So I think it's all this. I32 const, I32 load, I32 store, and then all of this add sub, blah, blah. I mean, this is really the... This is really the bulk of it. So I think that's all of the like I32, I64 type stuff. And then all of that is just the rest of it. God, there's an awful lot of that. I mean, that's not really breaking it up very much, is it? But it is at least now there is a sort of a top level division between all of the stuff that's actually I32 and I64 related versus all of the other stuff. I mean, is there a way that I could... I think I'm just gonna commit this, because at least it's divided things up a bit. I mean, this whole thing here needs to go into here. But it does feel like all of those numeric instructions are now standing apart and therefore could be extracted into... Yeah, I mean, that's obviously working. So let me just, I mean, that's not a big deal. But let's just say handle numeric instructions separately. And I think really the purpose of doing that is that makes it at least possible to extract all of that stuff. So all of this stuff in that arm of the conditional, I think, can now be its own, well, I guess including this. Yeah. Yeah. Basically everything in that whole thing. And then this will just be evaluate numeric. Evaluate numeric. Instruction? Again, I don't know if instruction is the right word here, but I mean, I'm giving it the same signature as evaluate because it's just going to be, it's just a piece of evaluate that's been pulled out. Evaluate numeric operation. Yeah, thanks, Kevin. Oh yeah, you're right. I called the regular expression operation. Hold on, I got itchy paste buffer. So this is evaluate numeric locals. Yeah, I should probably be consistent with my... Well, the thing is... The thing is, I'm talking about, like, what gets evaluated is like the instruction and its arguments. Whereas this regular expression, like, only matches the instruction part. But yeah, why I called it operation, I don't know. Oh. I think I'm just going to go with this for now. Basically, what I need to do here is, I'm going to say something like, get serious about the names of things. What is an expression, instruction, operation, body, and then that means I've just exactly, naming things is well known to be a pain in the butt. So I'm just giving myself permission for these things to be named wrong, I think, so that I don't, spend most of my brain power on thinking of good names for things. So hold on, does this work? No. Wrong number of arguments given. Given one expected. Okay. So what have I done wrong? Oh, I need to deconstruct expression, I think. I thought I'd done bits. Oh, I've got to... Yes, I'm sorry. I have to... Okay, right. Okay, look. I need all of this. All of this stuff is important. So I need to pull the instruction and the arguments out of the expression, and then I need to... This is no longer a condition, because I just want to unconditionally do this. Okay, and then that makes me think that up here I actually don't need this pattern match anymore because I'm not doing any... That's just telling me whether it will succeed if I go into here. So I think that's... Okay, yeah, that looks good. So, I mean, this is going to be a massive... Yeah. unfortunately. Although if I say ignore space changes, is git oh yeah, it's that's sort of an improvement. Kevin, you are saying switch to match question mark and it won't bother setting locals or globals. Oh, right. Yes. Good point. Of course. Thank you. So the point that Kevin is making there is that this method that I was using returns match data, and it also, I mean, can match set locals? This was the thing that Afuk was talking about with the equals tilde. Does match do that as well? Or is it just the equals tilde operator? But anyway, match with a question mark will just return a Boolean, and I don't think it sets, without updating $tilde and other related variables. So that is an excellent point. Thank you, Kevin. Good spot. Oh, except not that one. This one. It's important to change the right one. Okay. Okay, cool. So I think this is just extract, evaluate, numeric instruction. I'm not going to say any more than that because that's literally all I've done is just extract a method. So another thing that I'd like to do here before I start plugging the stack into everything is basically consolidating. So like, for example, here I've got, this is the implementation of const, but it's split into two in the same way that those, signed and unsigned or saturating or unsaturating implementations of truncate were split into 2 or 4 or 8, because I don't have an easy way to get at the type of the operation. But it occurs to me that that's just something that I could retrieve from this regular expression. So I sort of think if what I want to do is try to consolidate some of these, then whether it's a float or an integer is like a relevant piece of information, because then I could, what's the code that I want to write here? I guess I could what I really want is to switch on the operation so that I can say in const, and then I guess I need to know the argument as well. So if this is case operation argument, so basically if I've already in bits I've already got like this, if this gave me, I know type is not quite the right word for it, but if this told me whether it was an int or a float, then I'd be able to say case operation and argument in const value, and then I would be able to say, like, depending on the type, if it's an integer, then this, and if it's a float, then do this. And I know that there's still a conditional inside it, but now I've sort of, as much as possible, I think, consolidated the implementation of this const instruction, whereas previously it was there was no single place where it lived. I don't think I'm going to extract this as a method because that's slicing it a bit too fine, at least at this point. But I think the idea of having these things consolidated together is probably a good one. And then I guess I would need sort of an else. I don't really want to put returns in. And then these. Yeah, am I going to be able to... So Kevin's saying if you wanted to flatten that into a single case expression, it might be nice to put operation and splat arguments into its own object that you can then define deconstruct keys on yourself. Oh, right. I see what you mean. Yeah. Sort of make operation available as a thing that I can match against in a pattern match rather than have, I've got these sort of two separate conditions. Yeah, that's a good point. Let me see how this looks. Let me see how far I can get with this. Yeah, do I want to... Right. Yeah, I see what you're saying. I think what I'm going to do is, because I'm hoping I'm going to get through this fairly quickly. Like, I just want to push the food around my plate a little bit here until I feel happy that there's less duplication than there is at the moment. So I think I'm going to hold off doing anything more clever with the pattern matching for now, but see how long I can get away with that. It may well be that I need to have a smarter object to match against these patterns. Yeah, I'm having trouble deciding whether that's something that I want. In any case, this isn't going to work unless I guess this is what I'm calling type. And then, I mean, I could just use F or I here. Do I want to... I suppose I might as well, given that I'm doing this conversion of bits, I might as well do some kind of like type is, because this is going to be a string at the moment. So I could do this. And then that at least lets me, this code that I wanted to write, I actually can write. Yeah, I mean, this all feels a little bit rough and ready, but I think my fear at the moment is that I'm going to end up spending this whole session just refactoring this evaluate method. So I think I'm going to try and keep the pace up and just kind of hack and slash my way through this. And then, yeah, I'll come back and see if I want to have a smarter object as the subject of that pattern match. What did I do here? So this is like determine numeric instruction type from name. Not very descriptive. And then what did I say about... I'm just going to say handle const instructions separately. Again, not particularly clear from the... diff. I think that makes it clearer, doesn't it? That like all I've done is pulled those const lines out and put them inside a special match that's just for them. Okay, I feel slightly better about that. So I suppose, like, can I justify this? The thing is, the reason all this stuff sits up here, like I was just trying to remind myself, like, why is this up here and not down in the I32, I64 general section down here? And the answer is because all of these these are sort of like the vanilla instructions that are eager, that just evaluate their arguments, because their arguments, at least in the programs we've seen up until now, sorry, I'm reading the chat. You could put numeric operation regex in the pattern match itself, then delegate it in the body of the in clause. That way you don't have to have two different case names. Oh, right. Oh, well, at the moment, yeah, that's a really good idea. Let me just finish my thought. What I was saying was, all of these ones at the top are there because they've got special argument handling. So I think I'm just going to put that in the commit message and say something like, these have special argument handling. Like, that explains why they're being handled separately from all of this, like, add and sub and mull and stuff. Is because these sort of immediate arguments that they have actually have a special meaning, that you can't just evaluate these. They have to be run through a particular parser to make sense of them. I think for now, I'm just going to keep chewing away on this and see how far I can get through it. And then I think it's quite likely that I'm going to get tied up in knots with how complicated this method is, in which case I'm going to have to deploy something a bit more clever, I think. However, that being said, I think all of this stuff here, load and store, can be promoted up into this same thing, right? Like, all of the duplication in these patterns that's to do with the type, I think, can go away. Right, so this is already, like, just cutting this stuff away is making it much easier for me to see what I've actually got here, which is that I've got two implementations of load, one of which has got a static offset and one of which hasn't. And like I said, I'm pretty sure that I can combine those, but I'm just going to keep my eye on the prize for a second. So that's that. That's that. So does that just work? Yeah, because I left the arguments alone. Let me just test that. Yeah, I mean, that's quite promising. I think being able to take a list of 4 different instructions and coalesce them down, it's like, oh, these are all the same operation, they just vary in their type and their number of bits. Like, this is the kind of thing that was giving me the willies before, and I think I'm already starting to feel a little bit better about the fact that there's not so much noise in this version of the code. Like, when it moves over that boundary, it becomes easier for me, at least, to read and understand. So let's say handle load and store instructions separately. These also have special argument handling. Okay. I mean, can I just carry on like this? I think that probably I don't need to do this. I think there can just be one implementation of this where I mean, ultimately, the implementation of this is memory.load offset plus static offset, and then I just need to write some code here that makes it work. Whether it's there or not. I'm just going to have a look at the WebAssembly spec core. At this instruction, this load instruction. Structure. Memory instructions. Load memarg. Oh, well, that doesn't really tell me anything. Execution, maybe. Oh no, that's way too much information. I just wanted to see. Oh, I guess this is, sorry. It was taking me to the right place. It just, nothing happened, and so I didn't realize. So this memarg argument. So this curly braces indicates a record. So I think in the S expression, it's kind of like offset equals and then align equals. So there can probably be two things there, but all I've needed to implement so far is when either offset is there or none of them are there. But I think, given my previous problem with naming things, I'm going to have a splat in here that's memargs. Maybe, yeah, for me, it's going to be either 0 or 1. It could be 2. And then the offset always has to be there. At the moment, it's not here because actually the offset comes off the stack, but we'll get there. Just not yet. So those two lines are the same. So I just need to arrange for static offset. So like if present in memargs, then set it. Else it's going to be 0. So it's going to be something like this. So I think I can just say if memargs in right, if it's in this, if this appears like that. So this could be the empty array if there is no static offset, or it could be an array with one element in it. And if it's an array with one element in it, then I want to know if it's an offset. So, because what I don't want is this to explode when I find an instruction that invariably has an align in it. I don't want to accidentally match that here. So let's say if memarg's in that pattern match, then this thing here stays the same, I think, because that's just what we were matching in the pattern before. And now we're just saying, okay, so, and now we're just saying, give me what you were giving me before, or give me 0. I mean, obviously I could do another pattern match here to get the, yeah, I could extract this into a, I can see that this could be nicer, but ultimately just reducing the duplication there, even if this code could still use some polishing up, was sort of what I wanted to get out of this. Ruby -i dot wasminer rb. I just want to run spec test core. What's it called? Float memory and float express, because those are the ones that actually use these instructions. Yeah, I mean, I think that's inside tau, so that's failing in the way that I'm expecting. So I think load is working okay. It's the memory one that actually exercises the load and store instructions, and that seems to be fine. So can I do the same thing here? Because this is exactly the same deal. Well, not exactly, but almost. So what's this? Offset value equals, so that's the same, that's the same, that's the same. I just need to have the same thing. Okay, so if this is in store memargs offset value, so those are all required, but memargs could be the empty array there. So now if memargs in this whole thing Oh yeah, I'm setting static offset. Static offset equals, if memarg's in blah, else, I mean, I could have just copied this from above, couldn't I? It's exactly the same. Oh well, you live and learn. Yeah, so there is still some duplication there, but the substance of what we're doing is different. We're either and the arity of these instructions is different. Like I was talking about, sort of trying to organize things by arity. This one takes two arguments here. The memargs is really part of the instruction, but these come off the operand stack, and this one only takes one, so they're different in that respect. It's just this code to compute the static offset is something that could be shared, and the regular expression and stuff. All right, so again, okay, I'm gonna say that that's probably fine. Let's run all the tests just to check. It's looking pretty hopeful though, isn't it? Yeah, that's where we got to. Okay. Combine implementations of load and store with and without static offset. All right. I'm going to keep doing more of this cleaning up in the hope that it's going to get me to a point where I feel confident introducing the stack. So let's see how that goes. Well, I'm conscious that there's code here, like reading on. This thing here is really just checking the. This is really just checking the type of the expression. Arguments is already being. In fact, I could have removed this before. We don't need arguments there because it's irrelevant. That we've already got that local variable is what I mean. And this regular expression here is just matching integer. So I think because I think that there are only two cases here. I think there's this one, which is all of the integer operations, and then a long way down this one, which is all the float operations. So if this one was just in float, and this one was just in integer, and instead of case expression, this could just be case type. Does that still work? Yeah, okay, well that's an improvement. And it means I don't have that, I'm not reassigning to that splattered arguments for no reason. Check instruction type instead of whole expression. There's not very much to say about that. Well, so now I think, having done that, so basically I've got all of these instructions here, const and load and store. They've got the special argument handling, whether it's to do with having to pick a special parser or dealing with the presence or absence of the offset immediate argument thingy. But all of these things, like this is all just standard, like, I think I should be able to pull this out into like evaluate integer instruction or operation or whatever I called it. And likewise, this could be extracted. So, because these, apart from those exceptions at the top, these are all very regular. Like everything inside here it's all just pre-evaluate the arguments. Oh, and then we mask it at the end. So I think that whole thing could be evaluate. What could I call it? Integer instruction. and then it needs operation and arguments, and it's going to need the locals to evaluate those arguments. Operation, arguments, locals. So let's do that. Oh, it's going to need bits as well, isn't it? Because that's, yeah, when it does the masking as well. Okay. So I need operation. Arguments. Locals. Just trying to think, where does bits go in this? Sort of goes with operation, doesn't it? It's like it's a 32-bit or a 64-bit add, you know. And then the arguments and locals are a little bit less involved. They're involved later on than in the decision about. Yeah, so here, yeah, okay. All right, operation bits, argument locals. So up here, operation bits, arguments, locals. Does that work? Looks like it, doesn't it? I might as well do float in the same commit. Is that it? No. There it is. So this is going to be evaluate float instruction, operation, bits, arguments, locals. So, I mean, these are still massive, but it's starting to feel slightly less massive. Okay. And it's not rocket science, but I think it's starting to make at least this evaluate method is now, this evaluate numeric instruction is sort of easier to handle now, because actually most of the work is done in these other methods. And similarly up here, we've got all of these things that aren't I32 or I64. So this has got things like getting and setting locals, blocks and loops, and conditional jumps. That feels more organized to me. Failed successfully. Okay. So let's just say extract, evaluate integer instruction, and evaluate float instruction. So that, I guess that's, I'm just trying to think whether this is actually, is this making me feel any more confident about starting to jam a stack into it? Well, not really, because, well, I think I would feel better if I was able to say case operation in add sub whatever, and then inside here say like these have all got 2 arguments, and then here I could say in, I don't really know, I think it's called value. Yeah, CLZ, CTZ, pop count. An if statement after the in that checks the argument count. I don't know what you mean, sorry. Well, right, but the point is that I want to have, what I want is to have something like this where it's not about checking it, it's about getting it. So I want to put myself in a situation where when it comes time to retrieve these arguments from the operand stack, I don't want to go and edit 500 lines of Ruby. I wanted to be able to do a targeted strike and say, like, this is just popping one value off of the operand stack and this is popping two values off. So that's my motivation here, is to have an alternative organization of this method that where I've moved all of these. I mean, basically I'm basically doing it. How many of these can I just hoover up? Where's the left, right? So it's all of these. Yeah, I mean, I was doing this as like an illustration of what I wanted, but I think I'm just gonna do it. So all of that, those are all binary. I need to escape this. Oh, this is the same mistake that I made before. Right. In. One day I will learn what things need to be escaped in Vim patterns. So this has let me remove a lot of the operand ceremony, because previously I was having to repeat left, right, left, right, left, right after every single one. And it's allowed me to sort of centralize the retrieval of those operands, which is the thing that I'm really concerned about. Unfortunately, now I need to... I mean, I guess I could check the argument length here. Maybe this is what you were saying, Kevin. I don't actually need to know the names of all of these operations. Oh, but no, but that's the kind of thing that someone who has an array of all of the arguments would say. Whereas I think the reason why I said that I wanted to organize them by arity or consolidate operand handling was so that I know how many things to pop off the operand stack if it exists. So I think I'm gonna... what's the best way to do this? Oops. What is going on with my Vim configuration? Huh. Maybe I don't have... I mean, this isn't an ideal thing for me to be debugging live on a stream, is it? Have I somehow screwed up my... Oh, I have. Sorry, just a sec. I thought I had everything all nicely set up on this machine, but it turns out I don't. Okay, well maybe... Let's try now. Because all of my usual Vim foo was not actually working properly, and that was upsetting because there's a lot of text editing to do here. Okay, so what I wanted was to be able to repeat a yank, but you have to configure that. Okay, there we go. Okay, well, let's see if that did actually work. What did you yank? Yay! You yanked it all. Not perfect, but close enough. I mean, that was a bit of a mess, wasn't it, if we're honest? Anyway. Oops. Okay. So there's, I mean, there might be more of those actually. Are there any more byte? Oh yeah, there's loads more. Sorry. Okay, and the rest of them are all unary, and then those ones further down were floating point operations. So okay, so I need to do those substitutions again. And then it's all these inequalities, isn't it? Okay. So let's just stick those on the end. That's better. Oh, I shouldn't have done one on the... But see, I'm getting there. I might not be efficient, but I get there in the end. Okay. Yeah, so this is starting... I can see that this is starting to come to, like, my desire to organize these things by arity has got some kind of rational basis, because this is starting to look like that sort of parser that knows how many additional things we're going to need. Oh, actually, this is a different category of thing, but nonetheless, if I have to pop stuff off a stack, this is the situation I need to be in, where like at this point in the control flow, I know that I need two things, whereas previously I was depending entirely on the fact that I had an array that already had two things in it, whereas that's clearly not where I'm going to be by the time this is all done. So now I need to do the same thing here. Okay. So that's all those. Yes. Okay. And then I guess this glues on the end there. Is that right? So yeah, whichever branch of this, whether we go down the binary or the unary side. Hey, welcome. Thanks for joining us. Yeah, so I've already done that. So yeah, whichever side we go down, we end up returning the result. And then this is the thing that masks it. Yeah, okay, I like that. I like that. That makes sense. Okay, well, I'm very sorry, but I'm going to have to do my... well, actually, I'm not sure what I'm doing. Oh, the CLs, yeah, I'm, okay. It's value instead of left and right. Yes. And it's still get rid of the square bracket at the start. Right, okay, so just checking the operation. I'm going to have to do my yanking again. Yank this. Oh, remember those truncations? Those were the days. Where's the middle? There it is. Okay. So all of those. And then I think just those ones, but including that. And that just goes there. Text editing. Who needs an IDE when you've got a text editor that isn't correctly configured? Okay, well, I'm convinced that that's working, I think. Okay, fine. So that's a big messy commit that's making a lot of noise. But I think what I've done is group integer operations by arity. So it's kind of tedious pushing text around, but I think having these well organized, this is exactly what I wanted, because now there's an affordance here where I can imagine making a change to support a stack that doesn't involve me having to go and edit every single line of this method. However, I think I probably don't have any choice but to do the same thing for floats now, because I need to obtain the same feeling about floating point instructions. So again, I'm just going to take this a step at a time so that I don't lose my mind. So here it's going to be in add or sub or whatever. Yeah, and these all take left and right. Another thing I like about doing this is that this is going to fail fast if I make some kind of mistake, right? Like if I end up going down this route with the wrong number of arguments, then this is gonna, and I sort of already had that, but this is actually slightly stronger because it's gonna select this path based on only the operation, and then if the arguments don't match, I'm actually going to get an exception rather than it just, well, I guess I would have got a pattern match failure previously, so that what I just said is complete nonsense. Ignore me. So what do I have here by way of, okay, square root is an example of a unary one. In square root, arguments into value. And then this is going to be case operation in add, in sub. And this is going to be case operation in squirt. Okay, so where are my lefties and my righties? See, these are... I'm just trying to think what to do about this with float situation. I'm going to think about that in a second. I'm just going to get these for now. Yeah, I need to try and remember that these need to all go inside a with float. So this is getting a little bit more complicated. But that's okay. I mean, the float instructions are more complicated, so I don't mind a bit of essential complexity. So add sub mul div, copy sign, and all of these inequalities. That's it. But those ones, crucially, are not inside or with float because they don't return floats, I want to say. I think that's true. So these ones can just be straightforwardly, that was just my example. These ones really are just in the, you know, if the operation is copy sign or if it's eq any blah, then we can just immediately do them. This one needs, we need to check that it's one of these. So it's sort of in, add, or sub, or mul. Kevin, what are you doing? Let's see what Kevin tweeted me. Oh, thank you, Kevin. I'm gonna resist the distraction right now, but I'm very grateful that you've written me a cool gist to make my life easier. So okay, hold on. So if it's in add sub mul or div, then we need to start a with float block and do these things. Otherwise, we've got copy sign, blah blah. Oh, I just realized these are also, this min and max are also binary. It's just that they're not called left and right because I stick them in a little arguments array. In fact, I'm going to have to do that here. So this is I'm gonna have to be careful when I do this thing, because I don't actually want that to touch. Okay, so add submul div min max. Yeah. So I think those are the ones for the with float. So that forms the beginning of this. But now I also need copy sign and then all of those. So those need to go on the end. So these are all the binary floating point operations. So we pull left and right out of the arguments. Then if it's any of these ones that return a float, then we use the with float helper around them. And this one kind of reconstructs the arguments, which is fine. Oh, this... Hold on. The whole point of this... Yeah, the whole point of this is to get rid of the dependency on this arguments array, which I'm anticipating we're not going to be able to use after we introduce an operand stack. This is okay because I'm just synthesizing one out of left and right. But yeah, I shouldn't be using it in with float here. I think all of that is okay. So what's going on here? Oh. So what was this? Add submul div. Okay, what ones have I already taken care of? All of those. I've done min and max. Okay, but now I've got all of the unary ones left over is the point. Is that right? Yes. So these, I think, are all unary. Right, and I want to have an in, abs, or whatever, so that I can... Did I do an example of this? I guess not. In, add, blah, blah, blah. Okay. I'm getting confused about this. I'm going to comment these out because I'm... so here I want to say arguments goes into value because we know that everything in here is going to be unary. So there's... These are all unary. Yeah, and these are the ones that need like special handling because they're inside with float. So this is case operation in square root or blah. So that's really the first one, isn't it? Then we get that with float. Else, everything else. So all of these, well, it's not else, is it? It's, these are just alternatives. Yes. So there's too much ending down there. So I think this is right. I mean, this is right on the... I'm sorry, this is very dull text editing, but like this is what writing software is like, isn't it? I mean, I'm just trying to sweep all of this junk into the right sized piles, basically. So this is no longer arguments, it's value. This is value. This is just case operation. All of these need my patented, all of these, in fact, need to get rid of value, I think. And they all need to get rid of in. I hope I haven't accidentally replaced anything important by doing that. So let me just read through this. So if it's square root or floor or seal or truncate on nearest, then we do that inside with float. And then here are the other ones: abs, neg, convert. There's potentially I could have combined these, but apparently that didn't bother me enough to do it. Okay, that all looks okay to me. So now I just need to put together these operation lists. Convert, promote, demote, reinterpret. Okay. So hopefully that is... I think that's all of the operations. And this subset of them, I think it's just those ones, are these: square root, floor, ceiling, truncate, and nearest. Yes. Okay, well, let's see what happens if I run the tests. Wow. Well, no one is more surprised than I am that that works. Okay, great. All right. Well, as I say, I'll continue to apologize for how dull this is. But this is very therapeutic. I feel like this code is so much better organized now. Like, I feel like it's still not fully under control, but it's way closer to being under control than it was previously. And yeah, thank you again, Kevin, for writing that gist. I'm really looking forward to getting my teeth stuck into that when I'm not in this like rabbit in headlights mode when I'm on the stream. I think if I'm going to sit down in my armchair with my smoking jacket and read your gist at my leisure, I will enjoy that greatly. Okay, all right. So I think that has given me enough courage to actually start on the task at hand. I mean, it's been 2 hours of just, pushing piles of characters around. But now I think I can, now that I've got those I've got those instructions grouped by arity and cordoned off into the ones that operate on integers, the ones that operate on floats, and the ones that are neither, because they're things like getting and setting local variables or loops or whatever. I feel like I can get a bit more of a grip on it now. So that's to done. I think this is sort of to done, although I'm kind of double dipping there. And on my plan to introduce an operand stack, that is now item 1 ticked off. Reduce duplication, consolidate operand handling, break up into multiple smaller methods. I think that arguably I've done those things, so I'm going to claim that as being ticked. Okay. Well, then it's time to introduce a stack. What could possibly be more exciting than that? Where does the stack go? How do you introduce a stack? Well, I can see that I've gone with local variable here to hold the functions and instance variable to hold the memory. I think the stack is sufficiently important that it deserves an attr accessor. I mean, I really need to sort this out. Why is memory just in an instance variable like that? What was I... let me just... why is memory in an instance variable? Why is functions just a local? What is happening? I think what's happening is that I am missing some kind of context object, but I don't know what to call it. So I'm shying away from making it. That's my high-minded justification for that. I mean, the real reason for it is because I've just been panicking and hacking in whatever to make it work, but, you know, it sounds more intelligent when I put it that way. Anyway, empty stack. I mean, that is... I mean, I'm basically done. Introduce... Can't even spell introduce. Introduced an operand stack in the interpreter. Right now we're relying on every instruction having... well, being written in prefix notation, i.e. the operation comes before the operands. But that's apparently not true in general for WebAssembly. E.g. see the tau function in float expras.wast. So we need to maintain a stack to push results onto and then consume them later. I'm not yet sure how this interacts with the existing code we've already seen where the arguments come after the operation, but I expect I'll find out soon. Okay. Right, but like I said, I can... Yeah, my intention was to use... because the evaluation order is still... the arguments still get evaluated before the instructions. So the fact that the programs are not currently written in that way, the fact that the arguments don't actually come before the instruction is not immediately a problem for me because I control the evaluation order, and so I can make sure that by the time the instruction executes, all of the arguments have executed and pushed their result values onto the stack. So I won't put that in the commit message, but like I'm actually not that worried about that because I feel like that's under my control. All right, well, in that case, let's make a start on this kind of hand-over-hand incremental addition of the stack. So like I said, my idea was to go through and sort of, in a way that doesn't break compatibility with the way it currently works, which is using the Ruby call stack, just also push results onto the operand stack so that they're available, and then I can pick up those results from other instructions. So I guess the most obvious place to start would be these const instructions. Where are they? Oh yeah, they've I went to where they used to be, which was at the top of evaluate, but of course they have now been pushed all the way down here. So at the moment, the result of interpret integer, or the result of encode here, just gets returned from evaluate numeric instruction. But here I can tap in and I can say also push it onto the stack, the stack, not the git stash, although it's a very similar idea and in fact is a stack. So every time I evaluate a const instruction, in addition to returning the value, I'm also going to push its value onto the operand stack. So that means that if this const appears as an argument of like an add, then by the time the add instruction is evaluated, the arguments, which it could just as well collect from the return value of recursively calling evaluate, those values will also alternatively be available on the operand stack. And so let me just run this and check that it doesn't break anything. But I'm hoping that, I mean, const, thinking back, I think a lot of those early things I implemented, in fact, what was it? Integer literals had, I remember I had to implement recursive evaluation for this, because even in here there are some operations, but you see here this add has just got two consts as its arguments. So, well, I'll take it one step at a time. So this thing here is push const values onto the stack. For now, we keep returning the result for compatibility with instructions which currently expect the result to be on the Ruby call stack. I mean, this is what else is worth saying here? So could I have just why even bother doing a targeted strike here? Like, why not just stick this? Why not just make it so that the return value from all of this just gets pushed onto the stack? And I mean, maybe that would work, but I don't think it would, because whether a value gets pushed onto the stack depends on the instructions. So I think that's why I've picked one of these instructions rather than just saying, well, whenever we're evaluating a numeric instruction, let's just push its result onto the stack, because store doesn't have a result. At the moment, there's a 0 here, but that's really just a sort of a dummy placeholder to make sure that we don't accidentally use the return value anywhere. But store shouldn't return anything, and it certainly shouldn't push anything onto the stack. So I think it is important that, at least for right now, unless I refactor this more, which I feel like I'm sick of now, I think it makes sense to do this instruction by instruction, like paying attention to whether that instruction actually returns anything or not, because that's obviously a fairly crucial and relevant property of the instruction. So I'll say note that we don't want to push all evaluation results onto the stack indiscriminately, because some instructions don't return anything. Okay, so I guess my hypothesis is that if I were to run int literals.wast, well, firstly, that works fine. But then if I were to find add, just trying to think how am I gonna break that out. I suppose I can just do it in. I can at least for add. I'm just trying to think like when there's more than one, what am I going to do? But for this one, I can just say pop two things from the stack and put them into left and right. So I'm essentially clobbering what I've already got there. Yeah. So now, great. So I'll say retrieve add. Well, hold on. Let me run all the tests. That was a little bit rash. Okay. So although it does work here, it's obviously not going to work everywhere if it had, because sometimes add is adding things that aren't just i32 consts. So what's this doing? I'd like to find a sort of minimal slice of what we can. So this very first one is failing. i32 no fold comp s offset. Right, so that's just local.get. i32 const and the less than. So I'm just trying to think, like, how far am I going to have to go to be able to say that add can just read its operands from the stack? I was pushing const onto the stack. What would happen if I were to, because it's very easy, everything inside here, everything inside evaluate integer instruction does have a result. Like, none of these are things that have side effects or whatever. They're all just about computing a result. So I don't think there's any harm at all in down here saying, like, I'm going to tap into this value and push it onto the stack. So that's fine. And I suppose the same is true for float instructions as well. These are all just pure calculation. Undefined. Oh. Why is it saying that? What have I done wrong? Oh my goodness. How is that going so far? But I'm confused about. Oh, it's because I put it after the wrong end. That was very silly. But I don't really understand why that's, because local.get there isn't going to be the right, isn't going to put its result on the stack. So I mean, I don't actually understand how this is working, but it is. So what have I changed? So that was just push const values onto the stack. Oh. Right, so having... Okay. I mean, I'm not even going to stop to think about why this is working. I'm just going to accept that it does. So here, if we say push the result of integer and float operations onto the stack, because again, that's totally safe, then somehow... So this is retrieve add operands from stack. Right? Yeah. Somehow this works for all uses of add. Although I don't understand how that works in exprs.wast, where one of the arguments is a local.get rather than an integer operation or a const. Oh, yeah, I think that might be working by mistake, but I'm not gonna get sucked into that. The tests are passing, so I'm gonna take this as a stepping stone, even though it's a little bit wobbly. I'm pretty sure we actually need local.get to be working properly. So I'm to be pushing its result onto the stack for everything to be truly working correctly. So I'll do that next. Yeah, if anyone out there knows, I mean, is it just because the value, is it getting nil, or is it, I don't know, something fishy is going on there. But yeah, like I say, I'm not going to look a gift horse in the mouth. I'm just going to get on with it. So where's local.get? So yeah, here again, I think we can just say tap stack push. That's all looking pretty good, isn't it? Yeah, no, I wouldn't expect that to break anything. Push local.get values onto the stack. Doesn't do any harm. So now that add that I've done, is there any reason that I can't just do it for all of them? And essentially what that means is that. So we are not looking at arguments anymore. We're just popping them off the stack. And I realize that that's like a large bite to be taking, but maybe I've already got everything I need. Anything that's a const, anything that's a local get, and anything that's another integer or floating point instruction, although not floating point in this case, I would imagine, will be on the stack. Come on. Please pass. Yeah, I mean, this is looking incredibly promising, isn't it? Wow. Okay. I mean, I do notice that this float expras.wast is now failing at a different point, but that really doesn't sound like my problem. Previously, it was getting all the way to tau, and now it's stopping at some no trichotomy LT, but it's in a pending test, so I'm going to continue to ignore that. So what have I got here? Retrieve operands from stack for all binary integer operations. And can I get away with doing the same for all the unary ones as well? So where I have arguments into value, can this just be stack pop 1 into value? Yeah, looks like it. All right, I won't wait for that. Retrieve operands from stack for all unary integer operations. I mean, if I can just keep going like this, then I'll be done. Like, I just have to keep working through all of the places where I'm either returning values or accepting arguments. And then if I can, I mean, this is exactly what I wanted in my incrementally add the results to the stack, incrementally read the results from the stack. And if I can just keep it going, then I'll have a stack everywhere. So what's happened to my arguments? Can I just get rid of it now? The answer is no, because I need the side effect. Right. So if I don't evaluate my arguments at all, then they never push stuff onto the stack. So I do still need this, but this can just become an each. Because I'm not actually using, beyond this point, beyond this line, I don't think I touch arguments again apart from in... No, not at all. So I was going to say apart from in min and max, but for some reason that didn't... Did I call it something else? Am I just thinking of a different... Oh yeah, that's a floating point operation. Never mind, ignore me. So yeah, I just have to force their evaluation, but I don't care about the results. Okay. So I'll say something like, ignore the result of evaluating arguments for integer operations. These all consume their operands from the stack now. Okay. Can I do the same maneuver? Because I think this method, evaluate integer instruction, is fully wired up to the operand stack now. Like, it gets its operands from the stack and it places them back on it. So can this be the same? Here, can I say stack.pop2 left, right? Did I save that? Yes. Yeah, it looks like it. I realize I'm building up some, I haven't fully run my tests for a while, debt here, but they just take a long time. And once it's gone past a certain point, I'm just like, oh, it's probably fine. Retrieve operands from stack for all binary floating point operations. Is that... Yes. And then the next commit presumably is going to be unary. There we go. So stack pop 1. In fact, why don't I treat myself and run the tests in another tab so that while I'm agonizing over the commit message, the computer can be doing work. Retrieve operation stack for all unary. And then I guess I can do the same maneuver again of ignoring the result of evaluating the arguments. Okay, let's rerun this. The stream seems to be a lot better now. I've been having problems with like CPU utilization, but I turned some stuff off and it seems to be fine now. Okay. So surely I just did this commit. Ignore the result of evaluating arguments for floating point operations. What did I say? These all consume their operands from the stack now. Okay. I mean, I think I can just keep working through these, right? So basically, evaluate integer instructions, evaluate float instructions are all done. I've sort of started at the leaves of that tree, so this is all taken care of. Oh, I did const, so maybe I can finish off evaluate numeric instruction. So what does load do? So load says offset equals evaluate offset locals. So instead of using the return value of evaluate here, I can just force the evaluation and then pop offset off the stack. And then does the same thing work for store? Yeah, basically. Except it's offset and value, so it's got 2 arguments. And instead of this map, it's going to be an each. But otherwise, I think that's... I think that's a straightforward conversion. But what about the result of load? Store doesn't have one. Well, I mean, I'll see. It's obviously working without the result of load being on the stack at the moment. So let's just, again, if it doesn't break anything, then I'll definitely take that as like a hand over hand refactoring win. Yeah, I mean, that's a pretty small change. Retrieve, I type retriever every time. Retrieve operands from stack for load and store operations. I mean, that's all of the numeric operations, but I'm not putting anything onto the stack. Pending test failed successfully. Okay, well, I don't care. I don't care what the problem was. Index 1 billion out of string. Don't care. That's what pending tests are for. I mean, that probably is being provoked by something like this, isn't it? But I don't mind. So So here that's the return value here. And this is the sort of, in fact, I'm just going to remove that because memory.store is not going to push anything onto the stack, and I'm just going to leave that as is. This one here, I do need to stack.push the result onto the stack. And then I think that's all of these numeric instructions done. Okay. So what did I do? Push the result of load operations onto the stack, and store doesn't return anything. That's all the numeric operations done. Okay, we're back to tau here. So I guess, you know, this float expressions.wast is a much better stress test of all of this stack stuff than all of the other tests we've seen so far. But fortunately, these failures are just bouncing around at different points inside float expressions.wast, and they're not actually causing the build to fail because that is a pending test. So that's just great. All right, so we're kind of coming, you know, we started at the leaves here. We're coming up. So evaluate integer instruction, evaluate float instruction are like fully wired in to the operand stack. Now evaluate numeric instruction is fully wired into the operand stack. So I think I just have to go through the rest of these, and you know, this is the root of the tree. This is just the top level evaluate. I just need to fix all of them up so that they all use the stack, basically. Excuse me. So, okay, well, I'm not sure what return does. I mean, it probably does something in the world of control flow rather than in the world of the stack, right? Like, evaluating, this doesn't produce a value of its own. There's an expression, you know, return i32.const 5. That'll put 5 onto the stack, and then if we evaluate that, 5 will be on the stack, and then if we do nothing, it will still be on the stack. So I think from a stack perspective, this is probably correct. It's probably not correct from a control flow perspective, because I assume that return is supposed to jump you out of whatever block or loop or probably function definition you're inside. But we haven't got any tests for that yet, so I don't care about that. Local.get we've done. Local.set or local.t. So I remember from last stream that the difference between these two is that local.t local.set sets a local variable. Local.t sets a local variable, and it also pushes its value onto the stack. It returns the value of the local, like the t Unix command. The value sort of goes into two places, like a T-shaped pipe. I don't know why I'm doing the YMCA dance there. So I think that means that once we've got the value here, we need to say something like, well, push the value onto the stack, but only if the operation is local.t, which is not super beautiful, but I think that's the correct way to plumb it in. And also, just also thinking this is using the results of evaluation. Like if I'm I'm trying to decide how small pieces to do this in. I think now that I'm so close, I think I'm just going to convert everything. So again, this is a thing where instead of expecting a return value from evaluate, we're expecting a side effect from evaluate, and then stack.pop1 is going to go into value. I think that's right. Yeah. So we're sort of doing unnecessary. Well, this is a piece of cleanup to do afterwards. Is that like we actually don't need this argument in the pattern map? Well, we need it to be evaluated first. Okay, I'm not gonna get distracted by that. But there's clearly we're in like a weird in between state here where like we've got access to this argument when we don't really need it. We just need the evaluation to have already happened in the right order. But I'll figure that out once I've got the stack plumbed in. Okay, so this is now reading the value argument, because this name that's not going to go on the operand stack. That's like that doesn't get evaluated. It's just like part of the instruction, like the static offset is part of the whatever instruction has a static offset, load and store. So that's why we're not making any attempt to interpret that or evaluate it, I mean. What else is happening here? Block doesn't appear to really do anything. It just evaluates its body, but it's not doing anything with the result of that evaluation. Here it's at the moment it's returning 0, so I think I'm going to get rid of that, so that, I mean, just in the interest of if anything's going to have a return value here, I want it to be clearly being pushed onto the stack, and that 0 we're just going to ignore it. We're ignoring this 0 here. Here we need the condition. So at the moment we're using the return value of that. So I'm going to evaluate the condition, and then we're going to pop it off the stack to get its value. So again, I'm sort of double dipping on the local variable names here. Like this condition is an expression, but then it gets evaluated, which ends up pushing a value onto the operand stack, and now I'm popping that value off. So here I'm expecting this to be a number, which I can use in this conditional. This doesn't return any value, so I'll get rid of that 0 at the end. What about the select instruction? Oh, this is more of the same. So actually this is nice and easy to move around. So I need to evaluate all of the arguments so that they push their values onto the stack. And then here I can say stack pop 3 goes into that 3-element array. And then this returns value 1 or value 2. So I need to say stack.push, whatever the result of that conditional was. All right, all kinds of evaluation going on here. This is sort of interesting though, because, well, for the condition we need to do the same thing as up here. You know, the condition is always evaluated, and we need to know what it is to decide what to do next. So that always has to happen. But here, what we're doing is evaluating either the alternative or the consequent. And then this block was doing double duty. It was both evaluating that and returning its value. But here, I think we get that for free. That like when I evaluate alternative, that's going to leave the value on the stack, and I could pop it off and then push it back on again, but there's no point in doing that. I should just leave it on the stack. So that's just, I think that's it. You know, if the condition is false, then we evaluate the alternative, which is going to push something onto the stack. Otherwise, we're going to evaluate the consequent, which is going to push something onto the stack. So either way, that's how we return the result of the conditional. I mean, I'm assuming that the things you put in those leave values on the stack, but maybe they don't. Maybe they've just got side effects. I don't know what the validation semantics for WebAssembly are for conditionals. I mean, that's quite a lot of changes, but let's see if it has broken anything. Because if it hasn't, then I'm just going to keep going. I'll start writing a commit message since James called me out for writing those one-line commit messages. He didn't call me out, he just mentioned that I do it. I feel like I should actually open the editor a bit more. Use stack for operands and return values for all remaining instructions. That is, what was it? Local.set. Oh, and t. Block. Loop. Conditional branch. Select an if. All right, pending test failed successfully. Oh, it's complaining about if operation. Why was it complaining about operation? Have I made a mistake? Yes, I have. It's not called operation, it's called instruction. It's called instruction. So let me at least get that right. I mean, I don't mind that the pending test is failing, but I'd like it to fail for the correct reason. You know, not like a typo. Okay, there we go. We're in tau. f64.const does not respond. So that's, I guess it was worth looking at the pending test. Okay, instructions. See, there's all the more reason for me to get my story straight with my instructions and my operations and all of that business. So I will endeavor to get that straight once this code is working. Oh, all right. So the question is it now the case? So I think in all of these places, what I've been looking out for essentially is calls to evaluate and making sure that no one's using the return value. So how are we looking? Let's see. That's fine, that's fine, that's fine. That's each, that's fine. That's fine. Evaluate, that's inside an each. That's inside an each. That's inside an each. Okay, so all those calls to evaluate look kosher because they're just using evaluate for its side effect. They're not expecting it to return anything. So if I look through the rest of it, okay, well, this isn't going to work, is it? So I don't even know what that's doing, but oh yeah, this is getting the expected value. Okay, fine. Stack.pop1 goes into expected value. Now, when we're on the outside here, like we're in the when you're in the middle of evaluating a series of instructions, then the stack can be essentially an arbitrary size, right? But here, what we're doing is from cold, from outside of the evaluator. So this is like entering right at the top level and saying, can you please evaluate me? It's usually just a i32 const or a nice, F64 const or something for the expected value in a test. But even if it was a very large expression, my expectation is that by the time evaluation is completed and we get to this point, we're actually popping the last value off the stack. We shouldn't have a stack that's 10 items or 100 or 1,000 items deep. There should just be one value on it. And then this pops the very last value off of it, which is the result of the expression. So I'm actually going to say raise unless stack empty here, because I want to know if that constraint is being violated. Because part of what I'm doing here is trying to make all of the pushes marry up with all of the pops. And if I miss something and there's a mismatch there, then I've made a mistake, and I would like to know about that. So I'm gonna, because this is calling into it from outside, like I couldn't do this in general because the stack can be legitimately non-empty after you've popped a value off of it, but not in this case. Essentially because before we called evaluate, well, the stack was supposed to be empty. Like by establishing this post condition, I will make sure that the stack remains empty. But yeah, the assumption was that before we called evaluate, the stack was empty. Afterwards, the stack should be empty except for the return value, so there should only be one thing on it. So that's a very long-winded way of justifying this bit of defensive programming to make sure I haven't made a silly mistake. Next. Oh, invoke function. Okay, well, let's just do the usual. So this is going to be an each. So we're going to evaluate each argument in order, which is important because they have to come out the right way. Oh, this is actually supposed to be an array of argument. I was going to do my sort of pattern match thing, but I don't know how useful that is here. I mean, I don't know how useful it is in general, to be honest. This is just an assignment. This is just a straightforward assignment, so I think it's a bit too weird. So this is however many arguments there are, I should pop that many values off of the stack, and then that goes into the argument values. I think we're in the same situation here because invoke function only exists to be called from this top level. Like it's a script command, just like assert return. And in fact, this one is being called from inside assert return, but also you can do it just on its own, invoke function. So I think the same constraint applies. I think after we've popped, if I've evaluated, if the stack was initially empty, I've popped 3 arguments. I've evaluated 3 arguments and then I've popped 3 values off the stack. It should be empty again. So again, I'm gonna defensively do that to make sure that I haven't made any silly mistakes matching things up. Okay, so this final one. Each instruction in the function body, we assigned its oh right, okay, so this is just kind of trying to return the last one. Fine. I mean, I don't know if that makes sense, but I'm just gonna recreate the beauty of what we had before. So stack pop 1 goes into result. Is the same true here? Does the stack have to be empty? Well, I don't really know what it means for a function body to have more than one instruction in it. So I can't really say. My gut feeling is that it should be empty, but I can't really justify that because I don't really know what the semantics of multiple... Well, I mean, certainly that tau function. I'm actually quite unclear about what it is that I think I'm doing here. I'm sure I put this in for like a... Well, let's see. Why did I put it in? Minus L invoke function. Like, why did I... Oh, here we go. Store function body as a list of instructions, not just one. In general, we need to support functions with multiple expressions in their body, so it's important that our representation supports that. Well, I mean, obviously, there was a test that made me do it, and this was fine. What I'm going to do is I'm going to put this in and then find out if it causes a problem, because even that would be useful to know. Like, if the reality is that whatever it means for there to be these multi-instruction function bodies, whatever that means in this context, it would be useful to know whether the stack is allowed to be non-empty during execution of those. Okay. O. Length mismatch. Okay, well, something's gone wrong, hasn't it? Okay. Oh, hold on. I'm running the... Hold on. Wait a second. I was running the pending test. It's fine if that fails. I mean, it failed in a weird way that I wasn't expecting, but I don't care because it's a pending test. Oh. Damn. That's unfortunate. I have actually got a problem. Okay, well, that's all right. Let's think about what that problem is. So it's line 198 that's causing the problem. Oh. Okay, that makes sense. So maybe the deal is here that it's only the last one. So this, I think this error is saying... I think what this error is telling me, length mismatch given 0 expected 1, is that the stack is already empty. So this is returning an empty array, and then it's trying to pattern match it into this array that's got result in, which, by the way, is sort of why I'm using this syntax. I realize this could just be an assignment. I could just be saying result equals stack.pop, but that returns nil if the stack's empty, and then I wouldn't have got this exception. Although I guess I don't really want this exception because... Oh, so I think what I can do is just, instead of this, I think I can just put stack.pop on the end. Well, let me do this. So I think I can say, I don't know why this didn't occur to me before. I was focused in on the body of this loop without thinking about the meaning of it, which is that we really need to evaluate the whole body of the function, whether that's one instruction or 100. And then the only thing that's relevant is what state the stack is in at the end. So that's, I suppose, the answer to my question of whether the stack needs to be empty between each instruction. Well, I suppose essentially it doesn't need to have anything on it. Like, that was the problem. It didn't need to have any value on the stack, and that's why this didn't work. So that assignment of the result of evaluate would have been assigning nil or some kind of garbage value to a result. And it's only the final instruction that actually returns a value, which is equivalent to, in this world, pushing something onto the stack. So we pop it off. I'm going to do my sense check, and then we're going to return the result. So that's both checking that we don't get the empty array here. So it's checking that the stack isn't already empty, and then it's checking that the stack is empty afterwards. Which I could be doing those two checks just like by writing this, but then that won't mutate the stack to remove that result. So I think this is probably the best I'm going to get. So if I've understood that properly, well, I haven't. This is 199. Oh, that's here. Oh. Maybe it doesn't need to return anything. Sometimes, in fact, that's why we've got this invoke syntax. Here it is being used to compute a value inside an assert return, but I think the reason why we have this top level invoke command in the test scripts is that sometimes you're only calling a function for its side effect and it doesn't necessarily return anything. So how do I want to deal with this? I think I just want to tolerate it. So actually, I think what I'm going to do is say result equals stack.pop in the knowledge that that could end up assigning nil to result if the stack was already empty. But I still want to check that it was empty. It was either empty before or it's empty now, basically. And then this returns result, which could be nil. Okay, well now, if I've understood it correctly, then this test is going to pass. Okay. Okay. All right. Pending test failed successfully. Okay, well that was a bit of a palaver, but at least we got to the bottom of what was going on there. Okay, and that's more satisfying than what was there before, actually. So yeah, I'm okay with that. All right. So what's the change here? This is basically fix up remaining evaluate callers to read results. Well, to read result from stack. To read its result from the stack. I should put a note in here that says the invoke function helper might be calling a function that doesn't return anything, in which case stack.pop will return nil. That's I think that's fine. If anyone was curious about oh, that's a different. I was like, why is that? It's a different. If anyone was curious about why that's using stack.pop instead of stack.pop1 or something, then I hope that that message would explain why, basically, without me going into any more detail. I mean, this is making me think. I don't want to get hung up on this, but this is making me think about, like, should invoke function even be returning a value, or should it just be essentially this is just a wrapper for evaluate that does all of the hooking up the parameters and the argument values and the locals. Yeah, I think maybe that makes more sense. I think this stuff should probably live in the, because here we don't care. Like, nothing gets pushed onto the stack, and no one looks at the return value. Whereas here, I think I like it better this way. That, like, invoke function is just a fancy wrapper around evaluate. And then here we would have to say, what was it that this. What was it? Actual value. And then we don't need to return it anywhere. I think that's slightly, obviously it doesn't matter, but I think that's slightly cleaner in the sense that it makes it obvious that invoke function is not. I was kind of unhappy with the idea of it returning nil, basically. When I was writing that commit message, I was like, well, this kind of sucks. I think this makes it clearer that you call this for its side effects, and then you're on your own about whether invoking that function has left anything useful on the stack for you. I think that's more honest, and therefore less likely to be confusing, basically. It's not a moral judgment, it's just a practical one. I'll just make a new commit for that. Push the result of invoke function onto the stack instead of returning it. This makes it more obvious that invoke function is just a fancy wrapper around evaluate, and it works the same way. You call it for its side effect, and then you're on your own, and then it's up to you to retrieve anything you were hoping to retrieve, any possible results from the stack. Pending test fails successfully. Okay, fine. Which then suggests to me, in the same vein as failing fast if we've got a non-empty stack, I think potentially it would be helpful if here, at least while I'm doing this transition, I think it would be useful to return nil here, so that the result of function.body.each, which I think is just function.body, doesn't propagate out. And the same is true for evaluate, because like I said, this expressly doesn't return a value. Like, there are a few places in there where I was returning 0 or something as like a sort of a generic placeholder return value to show that, you know, that store doesn't return a meaningful value or whatever. But I think this is sort of defensive, but if I return nil, how does evaluate numeric instruction work? Yeah, I don't need to push it down to those two. I can just return nil here, because this is the only place that calls these. And I guess the same is true for this. Is the same true for this? Evaluate numeric instruction. Yeah, actually. Oh, and in fact, oh no, these all push their arguments onto the stack, don't they? I might as well do it in all of them. If I'm gonna bother at all, then I should do it in all of them. I mean, it's fairly pointless for these ones that are only called by ones further up the tree, but I think at least during this transitional period where I'm trying to introduce the stack, like, this makes me feel more comfortable that if there's any part of the code that's currently accidentally working because of it's using the return value of any of these methods in a way that I don't anticipate, then this is hopefully gonna break that, either now or in the future. So return nil from methods whose result is on the stack, basically. This will help us to fail faster if we accidentally use their return values. Okay. Pending test failed successfully. Yeah, and we're still all the way down in tau, so we're doing quite well, I think. All right. So I'm at an interesting point now because I think the stack is fully plumbed through everything. Like, everything is reading its arguments, reading its operands from the stack, and everything's pushing its result onto the stack, which is great. But at the moment, I'm still just evaluating these prefix notation expressions where the instruction comes first and then the arguments come after it. So I think I need to do some understanding of how and why we also have these. Oh, I was hoping for float expressions. Why do we always have this other kind of I don't even know what to call it, list of instructions? And how do I know which of the two? Am I executing something like this, or am I executing something like this, or do I need to support a mix of both of them? Because, like I said, this is clearly challenging with respect to, like, biting off the right amount of this iteratively requires a degree of cleverness that I don't currently, that my program currently doesn't have, and I think also probably I don't have. So I've done these two things. I have removed return values. Have I removed arguments? I mean, I think I have, because I mean, I know I haven't literally, because they're still here. But I think all they're being used for is this. Like, they're being evaluated. So that's what I meant, really, was like removing the use of the value of arguments and just get, oh, that's a different one. Yeah. So just scanning through this, I can't see anything that's directly using the values of those arguments. It's just using them to drive evaluation. Oh, except here, well, so these are a different kind of argument. These are, oh no, so here we're recursively evaluating it. But again, not using the result. I'm thinking about things like this, which is really not an expression at all. It's part of the syntax of the local get instruction, and here the name is part of the syntax of the local set instruction, and then the value is the argument, which, So I'm going to check this and say that we're removing the use of argument values. That's become quite tortured in order for me to be able to tick it off, but that's how the game works. What did I have in my list of here? No, just loads of miscellaneous stuff. I'm going to delete the things that are already checked while I think about what I want to do next. Because this is all part of the spirit of clearing the decks, isn't it? So yeah, I'm gonna have to read the WebAssembly spec. Like, I was trying to think, like, is there a way that I can experimentally figure this out? I think I just need to read the WebAssembly spec basically, and find out what the deal is with this notation, and figure out how I'm supposed to be thinking about it. Text format, because that's what this is. What part of the text format am I interested in? Instructions. Instructions are syntactically distinguished into plain and structured instructions. So plain is, down here. So hold on. Block instructions are these. So structured control instructions. So this is a bit confusing. They're called block instructions, but they are block, but also label and if. And then here it calls them structured control instructions. Right. So this is actually a different... This is about the concrete syntax, but this is slightly different than I've seen before, because it's got this end keyword. Right. And here, loop, end. So this block instruction, these productions here are talking about, this non-terminal here is this sort of block, optional label, optional type, list of instructions, end. And I think, yeah, this is sort of annoying, but these parens here around instruction, I can't even select this because it's fucking math jacks, but the parens here are not, that they're in the meta language, they're not real parens, because real parens get quoted. So this is just grouping for the purposes of saying multiple instructions can appear within a block, multiple instructions can appear within a loop, and here, if multiple instructions, else. Oh, right, because the condition is going to come off the stack. Is there an if in here? No. I mean, we've seen if elsewhere in this file, which is if x is less than y, then local get, else local get. This does not look like that. So these seem to be sort of more... This seems to be the more fundamental form. Like, this is what the grammar is saying, that a block or a loop is this sort of undifferentiated... I mean, I don't really know what an instruction is. Oh, this is the section we're in. Okay. Either a plain instruction or a block instruction. So we're going to get to what a plain instruction is, but it's explaining block instructions first. So a block instruction is this sort of sequence of atoms where it's like, quote, you know, literally the word block, and then optionally a label, optionally a block type, 0 or more instructions, then literally the word end, and then an optional identifier on the end. I don't know what that's for. And then these instructions can themselves be, according to this definition of instruction up here, there could be a nested block, or as in this case, you can have a block with a loop inside. So really the occurrences of these tokens, block and loop and end, are sort of demarcating, and these are sort of well nested. They're sort of marking out the boundaries of these block instructions. So that kind of all makes sense. It's just weird that I haven't seen them until now. Okay, so what's a plain instruction? All other control instruction, that should be instructions, are represented verbatim. Right, so these are all plain. So this is this like cumulatively defining plain? Oh yeah, okay, it is. I was like, why is it slicing them in this way? It's because it's going through each kind of instruction and then telling you which ones are block instructions and which ones are plain. So these are the other control instructions from this. So things like NOP and unreachable. And I suppose these are plain in that they don't have this kind of recursive structure that needs to have an end marker. It's just like, these are just straightforward, like an instruction called branch or branch if, and then it takes a label, or I don't know what a table is, or I suppose this is a function call. The else keyword of an if instruction can be omitted if the following instruction sequence is empty. Right, so if you write if blah 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 end and you never said else, then that just means that there's an empty sequence of instructions between else and end. That makes sense. Plain instructions, I don't know what references are yet. I think I've implemented select. I thought it would just let you choose between two options, but maybe not. Maybe I've got the semantics of that confused. All of these are plain instructions. We've done local get, set, and t. Haven't done tables yet. Memory, we've got load and store. So basically, plain instructions are normal instructions, and then it looks like, unless there are more further down, which I suppose is impossible to tell, that there are only 3 block instructions. These 3. Okay, well that makes sense. So ultimately we do need to be able to... Oh, and I mean, I suppose the point I was making, the point I made in my mind but didn't make out loud, was that these plain instructions, again, don't have any parens in them. So like syntactically, you know, things like all of these, you know, i32.const and all of the instructions that we've implemented so far, this plain instruction non-terminal here doesn't have parentheses. So when it says here, the body of a block can be 0 or more instructions repeated, that is what we're seeing here. We are seeing each of these is an instruction, which I guess informs some of my understanding of what words I should be using. Like, this part is not the instruction. The instruction is these two things together. That is the instruction. Local.get with an ID, that's an instruction. And so you can just have as many of those as you like. So that suggests to me that what we're seeing here is this is sort of the fundamental form of a WebAssembly program. Block type is given a years type. Okay, this is what we're looking for. In addition, as a syntactic abbreviation, instructions can be written as S expressions in folded form to group them visually. Okay, folded form. Instructions can be written as S expressions by grouping them into folded form. In that notation, an instruction is wrapped in parentheses and optionally includes nested folded instructions to indicate its operands. In the case of block instructions, the folded form omits the end delimiter. Okay, so that's what we've seen so far, is folded blocks. For if instructions, both branches have to be wrapped in nested S expressions headed by the keywords then and else. Right, that is what we have seen elsewhere. So this is a folded if expression. Okay. The set of all phrases defined by the following abbreviations recursively forms the auxiliary syntactic class folded instruction. Such a folded instruction can appear anywhere a regular instruction can. So that means, I guess, that here, if I'd wanted to make a folded loop here, or make this a folded block, then I could. That's totally fine. And in fact, I guess I could laboriously go through and manually fold this and edit it on the file system so that I don't have to worry about this. Like, I could convert this to a folded instruction. So here we go. For example, the instruction sequence local.get x, i32 const 2, i32 add, i32 const 3. I don't know why these are in parentheses though. Can be folded into. Right, and then this folded form is the one that I'm used to seeing. I think the parentheses here are just for the reader's benefit, because it seems that what folding is about is saying i32, so the multiply of adding x to 2 and 3, when that gets unfolded, it turns into a linear sequence of instructions that are now in that kind of postfix notation. Like the multiply has gone to the end, and now this is saying get the local variable x and push it onto the stack, push 2 onto the stack, then do the add instruction, so pop those 2 off the stack and then leave the result of adding them on the stack, and then push 3 onto the stack and then pop 2 values off the stack and multiply them. So this syntax for writing expressions is designed to be an abbreviation for what is actually going to get executed, which is this sort of linear sequence of instructions. So let's see how that works. So if you've got the set of all phrases defined by the following abbreviations recursively forms the auxiliary syntactic class folded instruction. Right. Well, it seems that a folded instruction is indicated by having brackets around it. And if you've got a folded instruction, then what you do is the first one becomes the last one. Oh, right. If you've got a plain instruction at the beginning, so if this isn't folded, then it goes to the end. Right, okay. And then if you've got blocks, you strip the parentheses off, and now it becomes the end gets marked by the end keyword. Same with loop. The end gets marked by the loop keyword. And if, oh, that's slightly more complicated because here you've got a folded condition. So this has to be folded. And then it gets moved in front. So that makes sense. So it's like you're going to have to evaluate the condition first, and then we're going to have this unfolded condition that's going to pop the condition that it uses off of the stack. And so this has these sort of nested then and else, and they get unnested and just written out straight. And again, these brackets here aren't syntactic brackets, they're meta-syntactic, because there's just so they can put a question mark next to it to indicate that that's... Although does star not already mean that? Anyway. Okay. So I think what this means is that, like, basically, so far what I have built is an evaluator for folded expressions, which is convenient because you don't actually need an operand stack. But these folded expressions are just abbreviations for unfolded ones. So what I need to do is change my evaluator so that it evaluates unfolded expressions, which will allow it to evaluate this, because this is already unfolded. But I also need to implement this unfolding transformation so that it remains compatible with all of the code that already works. But I mean, this is very strongly suggesting that the way that you evaluate this is that you have to unfold it. Like it says, as a syntactic abbreviations, instructions can be written as S expressions in folded form to group them visually. But these abbreviations really need to be undone for evaluation, because evaluation is defined on, here you can see these interpretations. I mean, I guess this is into... Yeah, this makes me realize that another thing I'm missing here is that I'm operating directly on essentially the concrete syntax, which is the S expressions, but really, and especially if I ever intend to support binary format, my interpreter really should be interpreting this sort of abstract syntax that this is being mapped onto. So this block and end, I think this is all... Yeah, this is all in this structure section. So this is like abstract syntax. Here's like the intermediate representation of WebAssembly that you can then interpret, or I suppose JIT or ahead of time compile. I'm not that sophisticated. I'm just chomping through an S expression. But at the very least, it needs to be an unfolded S expression. I mean, really, my interpreter needs a whole new phase. Add an AST parser that turns the S expression into abstract syntax. Then evaluate that. But I haven't needed to do that yet, and I don't really want to do that now. What I'd like to do is figure out how to at least get this code working by continuing to chew away on the S expression, but I'm going to have to... This unfolding transformation would be done by this AST parser if it existed, but it doesn't exist, so I think I'm going to have to do it as part of evaluation. Teach my evaluator to evaluate the unfolded expressions, not the folded ones, and then sort of shift that transformation left into the parser so that it emits an AST that is already unfolded, and then the evaluator won't need to deal with it anymore. But that's kind of a future problem. Right now, I suppose I can approach this in the same way as... I'm a bit intimidated by this, but I suppose I can approach it in the same way as I approach the... introducing the stack, because actually... every single one of these instructions has got its own little local chunk of code that knows how to evaluate it, right? So, you know, it knows what the syntax of that thing is supposed to look like. So for blocks, for example, it knows what a block is meant to look like, or a loop. There's nothing stopping me saying, oh, it should have an end here, and treating this as an unfolded instruction. If I've got an unfold function that only unfolds loops, then that's only going to affect the part of the code that deals with loops. So I think I can do this incrementally again, which is exactly what I want, because the prospect of, again, doing this as one large transformation, one atomic change, just seems impossible. But I think I can nibble away at it. I'm gonna make a start on it now and see how far I can get, because I've still got a little bit of petrol in the tank. So I'll give it a go and see what happens. Although I should mention that the other thing that worries me here is that I think it's clear that this evaluate function needs to take a list of, well, what I now know are called instructions. So right now, this expression is an array, but it's an array that's only got one instruction in it. You know, I know this is just the name of the instruction, and these are the arguments of the instruction. But for unfolded expressions, this needs to be not just a single instruction, but potentially a list of them, and it needs to sit in a loop, you know, until expression empty or whatever, you know, chewing instructions off the front of it. So that's another challenge. So I'm not quite sure how to deal with that, although this has given me an idea, which is that it's okay for a folded expression to just be a single instruction. So maybe I can hook up the unfolding, and I can make it so that when you unfold something, is that going to work? I'm not sure what I'm thinking. I think it might be possible to make it like stay compatible. Let's have a go. Let's have a go at implementing it and see what happens. Because if I can do it incrementally, then that's going to be fine. Just trying to think where to put it, because this numeric operation regex kind of lives with evaluate. So let's make an unfold. I'm not sure what this is going to do, but it is going to have to, I can see by looking at this that it's going to have to operate recursively on instructions. So like if you want to unfold, if you want to unfold some instructions, this doesn't really tell you about what the transformation is, but it does tell you when you unfold this, you sort of strip the brackets off of it and then you switch these around. Like, you would have to then recursively unfold folded instructions to get, if what you want is to have plain and block instructions at the end, you have to recurse everything on the right hand side here that is a folded instruction, you have to unfold it. So the basic shape of a function that does that is, so we take in an expression. If it's an array, if it's an array, which is why I need the square brackets in that pattern, then expressions.map, that autocomplete was terrible. Unfold. Else expression. So this is just the identity at the moment, but it's the identity sort of applied recursively over everything in an expression. So if there are lots of nested sub-expressions, this is going to unfold all of them by doing nothing to them, because this, anything that's not an array is just going to fall through to this, and it's just going to be the identity. But that kind of gives me the framework. So then if I wanted to say in block whatever, then that allows me to sort of, this is where I can shim in those incremental pieces of implementing expression unfolding. Now, where do I want to hook this up? I guess it's all the sort of entry points to evaluation. Because like I said, ideally the parser would have done this, and I would have received an unfolded S expression from the parser, but I'm not going to actually add this to the parser. And also, the S expression I get from the parser is not actually... Let me try and be more articulate. Recall that what we are executing here is not actually a WebAssembly program, is one of these test scripts, which inside it contains WebAssembly expressions. So this has extensions to the module syntax and stuff. So some of but it also has things like invoke and assert return and stuff, which is not part of WebAssembly syntax. And all of this talk about folding and unfolding and stuff doesn't apply to any of this stuff, because this isn't part of the core WebAssembly syntax. I'm just seeing if it says anything about folding here. It doesn't mention it. Oh, look here. WebAssembly is a stack machine, so that all expressions of the form op expression are merely abbreviations of a corresponding post-order sequence of instructions. For raw instructions, the syntax allows omitting the parentheses around the operator name and its immediate operand. So that's what we just read about. In the case of control operators, block loop if, this requires marking the end of the nested sequence with an explicit end keyword. Okay. So, that's what we already knew. But the point is, the S expression parser shouldn't be unfolding everything, because it shouldn't touch all of this rubbish. So even if it did know how, it shouldn't. It needs to go in the thing that turns the S expression into an AST, which currently doesn't exist. So I'm just going to find all the places where we sort of enter evaluation and do unfolding. So here we're doing it to get the expected value. Yes, that is correct. Here we're doing it to evaluate the arguments to invoke function. Yes, those are legit. Oops. Unfold. Here we're... Again, this is returning to my discomfort around what does it mean. Like, I think this is probably just wrong. Like, if the body is everything, is you know, this, and then this, and then this. So it's like a, you know, there's an opening bracket here, and then everything here is like an atom inside that list, and we chomp off all of these things that we recognize, get extracted and put in the function metadata, and then everything else is just an undifferentiated list of instructions inside the body. So this idea that we can evaluate each one of them one at a time is just clearly nonsense. So that does at least help to reassure me that my confusion over what we were doing here was somewhat warranted. But of course I still don't actually know what's going on. I mean, I suppose what I can say is that up until this point, we have a situation where everything that appears inside the body of the function is a folded expression. And so I think it would be fine to unfold it here. So that's true up until this point. It's not going to help us with this because I'm going to try to unfold f64.const and then I'm going to try to unfold. I mean, fundamentally, the problem here is that this is not a folded expression because it doesn't have parentheses around it. Like, there's an opening paren for the function definition, but there isn't another one here. So it doesn't really make sense to try and, well, it certainly doesn't make sense to iterate over these and try and unfold the very first atom and then try and fold the next one. I mean, it won't do any harm because of the way that I've currently defined unfold, but I don't think it's right. I think, I mean, I don't know if this is relevant to what we're doing at the moment, but I think, no, I'm just going to leave this for now. There is a problem there, but let me just see how far I can get without addressing it. I mean, essentially, it just doesn't. Essentially, we should be calling evaluate with all of the instructions in the function body, right? Like this idea of iterating through them and calling evaluate multiple times for the function body is just fundamentally wrong. But that's it's taken me until now to actually realize that, and I'm not quite ready to propose an alternative because right now you can't call evaluate with more than one instruction. It doesn't know what to do. So okay, well maybe I'll fix that up. Maybe that's the solution, is to fix it up. But for now, let's run the tests. I mean, that function is literally the identity, so it can't possibly have broken anything. Yeah, I think that's going to be fine. So let's say hook up a dummy unfold method to unfold expressions before evaluation. It doesn't do anything yet, but soon it will. Maybe I should link to folded instructions. but soon it will convert folded instructions into unfolded ones. Okay, that's a little bit more descriptive, although I don't like having that 0 at the beginning of the line, so let's just do this. Okay. Pending test failed successfully. We still made it all the way to tau. Everything is good. So the thing I was saying before is, I think what we need to be able to do is not this. We need to be able to do something like evaluate function.body locals on the understanding that this is potentially many instructions. I think probably each of them needs to be unfolded. Like I said, I think it's wrong to call unfold on the entire list, because if that was a folded expression, it would just be the first element of the list. It would have brackets around it, and it would be the first instruction would be a folded one. But like, because there's no syntactic bracket around these, I think it's formally incorrect to say like, oh, I'm just gonna, the reason I'm talking about this is I'm trying to think about, is it okay to, because I know that unfold is just going to recursively unfold everything inside it, so like, why not just do that? But I think the answer is that I know that function body is a list of instructions. It's not a single folded instruction. So even though arrays are sort of playing many roles here, I just think that this is not, whether it would cause any practical problems, I don't know, but like, I'm trying to build this thing on principle, and I would say that on principle, you can't unfold the list of instructions that is the body of a function. You have to iterate over them. And so I think that my only option here is to say, hold on, what do I want to say? I want to unfold all of the instructions. But like, if the function body was like, well, let's just say, you know, func foo, nop, unfolding, you know, here, if this folded instructions is empty, right? It's just a plain instruction inside brackets. It says that that's an abbreviation for the same thing without the brackets. So you sort of strip the brackets off of it. So that needs to unfold into func foo nop. So here, the body is, let's make these symbols. I'm trying to suggest Ruby syntax here. I know that they'd actually be strings with my parser, but you get the idea. Whereas here, the body would just be nop. So it's not enough to map, because unfold is just going to leave these alone. Like, unfold is just going to return the same array when I call it with each of these 3 items. So I need to, I mean, I guess this is why it's called unfold. I need to like unwrap it. So this needs to be a flat map, so that I'm mapping and then I'm doing one level of flattening, essentially joining whatever the result of unfold is I need to break off those outer square brackets and concatenate everything together so that like now I've unfolded those three folded no-ops to make a single list of three. So this is the point, right? Is that the body of a function fundamentally is a flat list of instructions. And in order to get that flat list, I have to, after I've done the unfolding, I have to flatten it because unfold potentially returns an array. Or in this case, for every folded instruction, it will return an array. And I think that's okay because flat map is not phased by... what I'm saying is, it's fine that only some of them... Like if I map... well, let's just map the identity over this. If I flat map it, it doesn't complain about the fact that 2 and 4 were not arrays. It just all gets flattened together into a single array. And I think this only flattens one level. So if there was something in here that was supposed to have some square brackety structure to it, then that would be preserved, which is also what we want. Although presumably that would be recursively unfolded and that structure would have gone away. But anyway, sorry, that's a very long-winded way of saying I think that this is what we should do. I think we should evaluate the result of unfolding everything in the body, but not the body itself. And then we sort of concatenate all those things together to get a big long list of instructions. But I assume that's going to break... Oh. No, I guess that's fine. So I suppose this doesn't make a practical difference. Because so far, we've only had... Well, but we do have one example where... Maybe it was calculate was the example. I was like, there was something that forced us to have... Yeah. So here, this is no good. And I mean, I realize this is a pending test, but like actually, if I had the technology, I would have said that it's only the tau test that's pending. Like this one was passing before, but now it's broken because evaluate only knows how to evaluate the first of these instructions. So let's see, has this... Oh, I mean, obviously, unfold doesn't actually do anything. I was going to say, let's check to see if it successfully unfolded it. Sorry, mate. You haven't written that code yet. But you can see that the flat map has worked. All of these have been essentially concatenated together. So you can see here, like, local.get and Z1 are like just undifferentiated values at the end there. And if I was unfolding this block, for example, I think those parentheses would go away. The ones inside the block, I mean. So how can I don't really want to break that calculate test because now that means I know previously I was like very happy to just break stuff, but that's because I don't know why I was happy. Now I'm less happy because I feel like I need to actually understand what the hell I'm doing here. And if I start allowing myself to backslide, then I'm not doing a proper like hand over hand refactoring of this. I'm just more worried about losing my grip here. Okay, so how can I... Is there a way that I can make this... maybe not. I can't see any way with the technology that I currently have to be able to sort of iteratively consume these inside the body of inside Evaluate. Like I would need to work that whole change through to be able to successfully execute this. So I think this is the sound of me reaching the acceptance stage of grief and realizing that I probably am going to have to backslide to calculate while I'm doing this work on unfolding, because this is this is where I get to something that I don't know how to evaluate yet. And until I've taught the Evaluate method to be able to, essentially the reason I'm hesitating is because it needs to know for every single kind of instruction. So for like local.set, and I mean, fortunately I've organized things fairly well in anticipation of, well, actually, no, this isn't about, I was going to pat myself on the back yet again for organizing things by arity, but this isn't about arity. It's about, in the concrete syntax, how many atoms make up this instruction, which is not the same as how many values it's going to consume from the operand stack. But here, like, we need to know that local.set consumes one more atom and f32.const consumes one more. And in the case of things like block, the answer is much more complicated because those can actually be nested. And like, I'm just not ready for Evaluate to be able to deal with that yet. So the fact that all of the existing tests are passing and we're in pending test failed successfully territory makes me think that I'm just going to make this change because I think this is right and it's not broken anything except for one of the pending tests. Change invoke function to evaluate the entire body at once after unfolding. I think this is the correct way to think about evaluating the body of a function which contains many possibly folded expressions. Unfortunately, well, the bad news is that the Evaluate method currently can't cope with evaluating a list of instructions. It can only evaluate a single instruction at a time. The good news is that the only tests that have multiple instructions in their body are pending tests. So we haven't actually broken anything important by making this change. I mean, it's essentially unnecessary because there's no test that's making me do this. It's just that it was doing my head in. That was the test that was failing, was my head. Okay, well, let's start doing some unfolding and see how far it can get before there's a terrible disaster. So let's try unfolding. Well, I want to try unfolding add. What would that look like? Oh, firstly, it's i32 add or i64 add is what I'm talking about. Integer addition is what I meant. and then it's going to have, if it's folded, it's going to have, it's going to be like this, right? It's going to have i32.add, and then it's going to have a left and a right. i32.add. Well, I mean, let's just think about this. If I've got an add instruction and then a folded left and a folded right, then what I want to do is unfold the left, evaluate that, then unfold the right, evaluate that, and then, well, I need this instructions, not the right word. So this is saying, if I've got a little 3-element array, so if I've got something that's folded and it's an add and then 2 arguments, then turn that into this flat list of whatever flattening the left consists of, and then whatever flattening the right consists of, and then finally the instruction. And then inside that flat map, this is going to get the outer brackets broken off of it, and it's just going to be a linear sequence of instructions as part of a larger linear sequence of instructions. I think that's the right thing. So we have to still recursively unfold the left and the right, but the point is we've moved the actual instruction to the end so that we don't evaluate it until the other 2 have been evaluated. Okay, so how do I support that on the evaluation side? Because right now the evaluator for this is expecting there to be 2 arguments for add. Here. Arguments. So where did the arguments come from? Oh, here. Yeah. So I think if this has been unfolded, then, I mean, I suppose this isn't doing any harm, but it's sort of doing conceptual harm, because in the case of add, let me just remove this from here. I do still want to, I want to pop left and right off of the stack, but I don't want to do any other evaluating, because by the time you get, if now that add is being unfolded, by the time we reach it, we don't need to do any other evaluation except for popping 2 numbers off the stack and adding them together. So I think this needs to move down so that, or at least for my understanding, it's like if it's an add instruction, then that's been unfolded, and so we don't need to do any recursive evaluation, because the recursive evaluation has been turned into just evaluate those sooner, and the results will be on the stack by the time we reach this. So I don't think I want that to be there. Was there more than one? Oh, there must be. Yeah, so that... I think that's it though, isn't it? All the binary and then all the unary. Yes. But this isn't gonna... It's not gonna get evaluated successfully, I don't think. No. In evaluate, undefined method match. Right, because that argument, that I32 const argument, has now been moved to the front. Let's have a look at what happens in evaluate. It's going to print out a lot of junk, but puts pretty print expression. Oops. So this is what's happened, is that the add has been unfolded. Oh, okay. Hold on. No, this is okay actually, because what we've got now is two folded instructions, and then the one that I actually want to evaluate. I.e., I sort of want this to get plugged into the evaluate with no arguments, right? I just want it to be an instruction with 0 arguments, which evaluate can do. That's fine. It's just that there's these two other things before it. But because they're still folded, I can see whether... Right. I think what I need to do, I think I'm slowly understanding what needs to happen here, which is that in order to support this, I need to make it so that evaluate can like spot that situation. Like it needs to say, if this expression looks like there's the first thing in this expression is something folded, and then there's the rest, then I want to evaluate that first thing. So in this case, I want to evaluate I32 const, which will be fine. Like that's a single instruction that I know how to evaluate. And then I'm just going to recursively evaluate the rest. And then I guess I don't want to put a huge conditional. I don't want to put all that in an else. Oh, do I? No, that's fine. I'll just do an early return. So what's going to happen there is that in this case, we're going to get this whole thing. We're going to spot that the very first thing is a folded expression. So we're going to try and evaluate that on its own, which we will successfully do. And that will push something onto the stack because it's a const. And then we'll try and... Then the rest of this, so these two instructions we'll call evaluate. And then the same thing will happen again, which is that we'll spot that the first thing is folded, and then we'll evaluate what's inside it, and that'll be fine. This will be the instruction, 1 will be the argument. And then finally, we will try to evaluate this, and it's not folded, it's been unfolded, so it will not trigger this condition, and then it will fall through to here, and then it should work. Great. So assuming that's working, I think probably I need to add this first. I need to say support unfolded instructions in evaluate, because that's what I did. That's why I needed to do it. When an instruction has been unfolded, the result is multiple instructions being sent to evaluate, which it didn't know how to handle. By checking for, I mean, this is going to be a problem when everything is unfolded. Oh, but I guess I can leave the parentheses around things for now in order to support this, and then I can remove them when I'm ready to do that. When an instruction has been unfolded, the result is multiple instructions being sent to it, which doesn't know how to handle. By checking for an initial folded instruction in that list, we can at least support unfolding instructions which leave their arguments folded. I don't really know how to explain that, but that's what we're doing here, is that this works because the two arguments to that add are still folded expressions. And actually, yeah, I should put something in here that says this won't be true in general, but I'm hoping that during the transition to evaluating unfolded expressions, I can leave brackets around the unfolded expressions to make them easier to evaluate, to make them compatible with evaluate. So actually, should I be, if that's what I want to do, should I be doing this and saying like, the instruction is actually, it's been unfolded in the sense that its arguments have been moved in front of it, but it hasn't been unwrapped. I haven't removed the parens around it yet, because those are what, yeah, this might be a cute way to slice up the problem actually, because in this case it doesn't matter because this thing doesn't have any immediate arguments like a label or whatever, but by packaging it up in these parentheses, I can allow evaluate to identify that it's a contiguous chunk of, that it's a single instruction basically. Okay, yeah, still complaining about calculate there. Oh no, that doesn't work. What does that mean? Length mismatch given 0 expected 1 plus. So where is that happening? 229. Why did I take out that? Why did I take out that pretty printing? That was incredibly. That was amazing hubris. Oh. Right. Then there's an empty array on the end. Obviously, we don't want to try to evaluate that. Unless rest empty. Does that work? Let me comment that out. I mean, that is doing something, isn't it? I mean, it's a bit clumsy. Yeah, still can't evaluate that. Calculate. Yeah, because this doesn't have, this hasn't been produced by my unfold, so these don't have brackets around them, so it doesn't know what to do with them. Well, I'm going to pretend that I had the foresight to think about that case, and I'm just going to stick that in this previous commit. So, what have I done here? Unfold integer add instruction. This also requires support, i.e. ignoring arguments on the, I can see this is going to wrap, on the evaluate numeric instruction side. Yes, I think that's okay. Okay. Okay, so if it works for add, then can it work for the other binary instructions? Basically, there's nothing special about add. It was just easy. It was just easy to pick on. But here I could certainly like it's easy to support on this side. Like now, oh, and I just take this out. Now that's the same as what I had before, but minus the expectation that there's any arguments to evaluate. What do I do on the unfold? So these have all got 2 arguments. This is going to be, oh god. It's not all of the, I was going to just write a regular expression that was like, what is it, begin, end, I 32 or 64 dot, oh, I suppose we don't want to anchor it there because that's the whole point. I was going to say it's all of those. Hold on, I left the brackets off from this. That's very naughty. Although that is supported, I think that because that actually made me really confused. I was like, it's supposed to be an array. It is an array. It's just the square brackets are optional. Okay, that's better. Okay. So I was going to say, oh, it's just anything that starts with I32 or I64. But I think that's not right because that also includes i32 const and i32 load and i32 store, none of which I want to touch here. So I'm afraid I'm going to have to say if instruction split on dot last is in this. Which obviously is now begging to be extracted out into something, but for now I'm in tunnel vision mode. I'm just gonna splat it in there. So, and these are all binary, so we can just still keep the left right stuff. Unfold. I think that's right. Seems to work. So let's say unfold the rest of the binary integer instructions. All right. I mean, that wasn't too bad. So what about the unary ones? Because I can see here that this could just be, instead of left and right, this can be just like the rest of that expression. You know, whatever comes after. And then here, let me just think about that for a second, because I want to make sure I get the map, v flat map situation correct. This is essentially rest.map unfold. Yeah, and that's right. It's not a flat map, specifically because we're not doing that final unwrapping step yet. Like, when I can get the evaluate method to be able to just chomp away at a single flat list of instructions, I can remove these square brackets and I can turn this into a flat map. But right now, I don't have support for that. So I think that what I've done here is just is a no-op. It's just a different way of saying what I'd already said here. But now, I think that if I take out this arguments.each here, yank all of those. I'm very sorry for the length of this line, but sometimes you just gotta roll a hard 6. That just doesn't make any sense, does it? I'm sorry. Okay. Yeah, I mean, we're going to be stuck on that calculate until we are able to chew through a flat list of instructions. So basically what we're trying to do now is a series of behavior preserving transformations that gets closer to being able to do that. But like step 1 is have all of the instructions unfolded in terms of reordering them, if not unfolded in terms of actually breaking those parens off and squishing them all together into a single long list of instructions. So, okay. Unfold the unary integer instructions. Trying to think if there's anything interesting to say about the implementation here. I mean, I guess this does, again, like with the... Like here... I think it does bear explaining why because this code might look like a mistake, because you might think, well, unfold will recursively unfold all of the, if you give it an array, it will recursively unfold everything in that array. So why are we mapping here? We could just say unfold rest, not have to do rest.map. But it's the same situation, that rest here is not syntactically a folded expression. It's just the brackets aren't around rest, they're around the rest with the previous instruction in front of it. So there's no way that rest as a solitary array could ever be a folded expression. So it would be incorrect to just call rest, to just call unfold on rest. So I think I should say something about that. It's important conceptually, if not practically, that we map unfold over rest rather than just calling unfold rest. Unfold over the elements of rest. Because rest cannot be a folded expression. We constructed the array ourselves, so it couldn't have had brackets around it in the original S expression. So this is really just hygiene. Like, it's probably not a huge deal, but it's helping me to like get it straight in my head what it is that we're actually trying to do here, which is of course the primary challenge of this kind of thing. So am I right now that has that just removed the last use of arguments in this method? Yeah. So that arguments, and I think locals as well. I can't undo that, but yeah, I know Git is here. So the arguments and locals were being used to force that evaluation, but we don't want to do that. We're not doing that anymore. So I think I can just take those out. Oh, I was going to look for the use of it, but it's right here. Yeah. Well, that's what we want. We finally got rid of the arguments. So that, I think that viscerally shows that unfolding is doing something, even though it hasn't given us a flat list of instructions. It's reordered the instructions in such a way that by the time we get to an integer instruction, we've already evaluated all of the things, all of the arguments, and they're already on the stack waiting for us. So that's pretty good. I feel good about that. Remove unused arguments from evaluate integer instruction. These all use the operand stack now. Great. Well, my primary motivation is to get rid of this big long thing. So, just because it's very unwieldy. I think probably the easiest way to get rid of that is to have cases for const. What else is there? Store. Load. So these are the ones where they sort of have, you know, I32 dot or whatever. So what actually, oh, it's inside evaluate numeric instruction, isn't it? Const load store. It is actually just those things. So if I catch those, I guess it needs to be, I know I could write a regular expression for these, but I'm being lazy. hold on, what order do they go in? Load and then store. So if I've got these here, then I can get rid of this big long, you know, because then I can just say, oh, any i32 or 64 that's fallen through these must actually be one of these other kinds of integer instructions, and then I don't need to enumerate them all like that. So, well, hold on. I haven't thought about this at all, have I? So these all need to be arrays again. What do I want to do in each case? Well, in the case of const, there's a value there, and we want to leave it there. Can I just leave this alone? I was going to put this in I was going to capture this into a variable and then build a new array, but can I just say expression here? Like basically leave it alone, don't unfold it. Because the argument to i32 and i64.const is not an expression that can be evaluated. It's like part of the instruction, so I think it has to stay there. Let me just and I don't think there's anything to do on the evaluate side. Yeah, that's okay. Load, what does that have? Actually, does this even make sense to be talking about I? Because they're not integer. Like if I need to make any change to this implementation, which the reason I paused there is because for load I do, because offset is actually an argument. Like what I want to do here for load is to say, well, load comes with crap, there are actually two cases here, aren't there? There's the one with the static offset and the one without. So this is a little bit more fiddly. Okay, so there are two sets of problems here. One of them is that these are numeric instructions, not integer instructions, so this needs to also be f32.const and f64.const, which is fine. All four of them are going to work just fine because they're not being touched. But for this one, i32 load, i64 load, f32 load, f64 load. Well, I'm going to think about this without the offset first, because I think that's actually quite easy. So if there aren't any memargs, let's do the non-memargs version. So we get a load and an offset. And then we just want to unfold the offset. And then we just have the instruction, right? I think. Now I'm expecting that the tests are going to break. Memory. Yeah, load, no matching pattern error. Because now I've taken away, it's expecting an offset in evaluate. Oh, I guess it's evaluate numeric instruction. Load is expecting an offset. It's also expecting memargs. Oh no, maybe that's okay. Maybe I can remove that. Because this memargs, the whole point of that is that it's optional. Oh, but I haven't unfolded the version of it with memargs. Okay, I'm going to have to do both. Sorry. So what does that look like? I think I'm going to be explicit about this. Yeah, static offset. There might be a way to combine these two things, but I'm a little bit too frightened to do it. So there's a load without the static offset. Or maybe I should put the more specific thing first. Yeah. The reason I'm hesitating here is because, and the reason why I'm being a little bit meticulous about this is that I'm imagining that at some point we want to be able to support no, maybe not. Maybe this is fine. So, yeah, what I was going to say was stupid. So, we've got the static offset. And I suppose in this version of it, we're saying that the instruction includes the static offset. And in this case, it doesn't. And again, putting the square brackets around it to sort of package this up so that even though it's been unfolded, it's still nicely wrapped up and nested so that evaluate knows what to do with it. So we end up with a flat list of nested instructions, not a flat list of completely unnested instructions. So at least this is giving us enough structure that evaluate is able to find the boundaries of the instruction when it chomps through that list. So I think now that I can just get rid of offset here and stop trying to evaluate it. Because now it's either going to be load followed by nothing, in which case we're going to get a static offset of 0, or it's going to be load followed by an actual offset, in which case we're going to parse it. And then the offset, which has been unfolded, should already be on the stack because it's already been evaluated. We've already done that. And now we're going to do this. So I'm actually expecting this to work. Yes. Okay, well that looks pretty promising. I know this is a lot of changes for one commit, but conceptually I just wanted to get these out of the way. So now what does it look like for store? I don't need this anymore. well, I'm basically going to need all of this, aren't I? But all of these loads become stores. And store has got another argument after offset. It's got value. So here we've got offset value. And here we've got offset value. And then we have to unfold offset, unfold value, instruction static offset, unfold offset, unfold value, instruction. Yeah, fine. Calculate's never going to work. Memory test. Oh, yes, I have to change it on this side. So the problem is this pattern doesn't match anymore because now it's not being called with the arguments. It's just being called optionally with memargs. The offset and value have been unfolded. So we just have to pop their values off the stack. So that was silly of me. There we go. So, I mean, that is a right mess, isn't it? It does occur to me that I can't type. I think I'm getting tired. What occurs to me is that here, whatever comes after static offset, everything here needs to be unfolded and prepended. So this thing here, in the same way as we did with the arguments to add and sub and, well, when we had to sort of generalize to different arities, because that's what's going on here, is that load has got a different arity to store. We can do the same thing. So we can just say, this is just the rest of that instruction, and this thing here is just rest map unfold. Same goes for this one. And if that works, then we can just combine the loads and stores because it works the same way. Let's just test the memory test. Yeah. Okay. So I think that's going to work. I think I can just all of these loads and all of these stores again, not the world's shortest line, but and then all of these loads. I know this is just the same thing again, but I forgot to save it. All of these stores. Oh, unfortunately, I've deleted the useful. Oh, that was so stupid. I'm sorry. Okay, so I've got this is rest. This is rest. That's the one with the static offset, and this is the one without. Sorry, I know I made a bit of a dog's dinner of that, but in my brain it made sense, even though on the page it was a total nightmare. Okay, that's still working. Okay, I think I'm well overdue for a commit there, and also increasingly overdue for bed. Okay. Unfold star.const, star.load, and star.store. We have to deal with integer and floating point instructions together because they share an implementation. But then the whole reason why I was doing this in the first place was in a desperate attempt to be able to get rid of that huge, to get rid of this huge condition, right? So can I now safely do that? If I say anything that gets through this frontal assault, we just, oh, it's this is actually the same as that one. There was so much mess there, I hadn't noticed that it was the same. That's interesting. Well, I want to see what happens if I just delete this one then. Because that, if this one is the same, that means it can fall through to this. Okay, well, let's be optimistic and assume that that's going to work. Oh, look at all that red. Simplify integer instruction. It's not just integer though, is it? It's got the float ones in it as well. Yes. Okay. I realized too late that that was too good to be true. But I can delete all of the I can delete all of the integer ones from it. But I've got to keep the float ones. Simplify. Oh, let's just check. Let's get the test running. But I think that's going to be okay. Simplify integer instruction unfolding condition. Now that all integer instructions are unfolded. I can't think of a better way of saying that. Okay. Oh. Okay. Pending test failed successfully. Okay, so I've cut down that condition quite a lot, but I've still got to have that the floating point load and store. That's okay. It's nearly time to stop, isn't it? I think what I'd like to do before I stop is just deal with this, because I think it's quite easy to do that. I think I can deal with all the floating point instructions the same way I did the integer instructions. I've basically already done the work. In fact, I think all I have to do is in here say anything that's a floating point instruction, because unlike with integer ones, we don't have these exceptions. If you look at it's all just completely straightforward. You know, evaluate the arguments. There's nothing special in here at all. It's completely regular. So unlike with the integers, I think this is actually completely straightforward. And then to make it work on this, make the unfolding work on this side, I have to not do this. Or, you know, that is no longer necessary once I've done the unfolding. Length mismatch. Oh. Well, it's finally happened. I've forgotten how regular expressions work. This, of course, needs to go into whatever that's called. I don't know the names for things. Character, class, group, thing. I mean, that is, if that works, that's very satisfying. Oh, ooh, I'll tell you what else is satisfying. Now I really can get rid of these because those really do fall through to this. So that was the... So I guess it is important that we don't evaluate those arguments because that was causing breakage. No, sorry, it was the opposite way around. We weren't unfolding those. The implementation expected them to be unfolded, so it thought the arguments had already been evaluated, but they weren't getting unfolded because they didn't match that regular expression if there wasn't a dedicated case for them. Okay. Well, that's looking quite promising. We're well into the floating point instructions. I'm just going to say unfold all floating point instructions. None of these have any special arguments or behavior, so we can unfold them all in exactly the same way. Hooray. And now I suppose we're in the same situation that we were in with integer instructions, that we don't need these arguments anymore. These are no longer used now that we've removed that stuff. Yeah, sorry, calculate. What did I say here? I mean, I'm lazy enough that I'm just going to basically reuse this. Okay, pending test failed successfully. Whew. Okay. I think that I am going to stop there because there's a fair few more instructions to unfold, and it includes the block instructions, which aren't going to be difficult, but they're going to require me to be able to think a little bit. And I think I can feel myself flagging and becoming tired. So, yeah, I'm not gonna risk it. Oh, but I have to push it up, don't I? So let's see the test pass, and then we're allowed to say that it's worked. I always have this real fear, because I've still got this, the original version of the spec checked out from weeks ago, and I'm always living in fear that they're going to add something, because this clones the latest version of the specs, and I'm worried that they're going to change something that's going to cause breakage. So this isn't entirely pointless. This confirms to me that the moving target that we're aiming for, that is WebAssembly, has not moved too far. Okay, gone green. Okay, that's a relief. All right, well, I think it's that time, which is the time for me to say goodbye. As always, thank you very much for watching this. This has been a really long one, and it's been mostly quite boring. I feel like I've got a lot of momentum, though. I can feel that once I've got the blocks done, the structured control flow instructions, once I've got all of the instructions unfolded, because I've got all of the integer and all of the floating point, and I think, is that all of the numeric ones unfolded? I'm going to be able to quite quickly get to the point where I can stop thinking about unfolding and just think about trying to make evaluate work with flat lists of instructions. That's the thing I was really hoping to get to. I've sort of run out of time, but next time, that's what I'm going to do, is finish unfolding, make it so that evaluate can chew through that flat list of instructions, and then hopefully, finally, that tau test is going to pass, and I'm going to be very happy, because that will be basically the end of that floating point test. I will have understood something about WebAssembly syntax. I'll have done a transformation on the concrete syntax tree, which is going to be an important part of the AST parser when I actually implement that. So I'm feeling pretty good about that. I'm sorry it was so long and tedious, but if you don't want something that's long and tedious, then you are watching the wrong YouTube channel. So thank you very much for joining me. I'll see you next time. Bye-bye.